Hello there, and welcome to Just About Earth, the quiet corner where curiosity slows down, big ideas take their shoes off at the door, and science wanders at an unhurried pace. Wherever you are right now, whether you're easing into sleep, resting your eyes after a long day, or simply letting the world dim a little around you, I'm glad you're here. Tonight's journey is a gentle one, not because the idea is small, but because it's so vast that it deserves time to stretch out and breathe. Before we begin, take a moment to notice where you are. What part of the world are you listening from? Is it late evening, early morning, or somewhere in between where time feels a little undecided? There's something fitting about asking that now, because the question we're going to explore tonight is deeply tangled with time, not the ticking clock kind, but the kind that layers itself quietly beneath our feet. If you find this space calming, thoughtful, or simply a comfortable place to let your thoughts drift, you're always welcome to like the video or subscribe. It helps this small pocket of calm reach others who might need a gentle place to land too. And now, with no rush at all, let's begin. Imagine standing on solid ground. Maybe it's a familiar place, a sidewalk you've walked 100 times, a stretch of land you barely think about anymore. Beneath that ground, far below the roots of trees, below buried stones and compacted layers of soil, lies a record so old and so patient that it rarely speaks unless we ask it very carefully. Earth has been keeping notes for a very long time. Not in words, not in stories, but in layers, pressures, folds and scars. And most of what it knows never reaches the surface. We tend to think of human history as long. Thousands of years feel enormous to us. Entire civilizations rise and fall within that span, leaving behind cities, tools, writing and bones. Stretch that timeline back a little further, and we reach the age of early humans, stone tools, fire, migration. Keep going, and the story becomes quieter. Forests replace cities, ice advances and retreats. Continents shift so slowly that nothing living ever notices. And then, beyond that, the scale becomes so large that our usual reference points stop working. Earth is about 4.5 billion years old. That number is easy to say and very hard to feel. If you compress Earth's entire history into a single calendar year, humans appear only in the last few minutes before midnight on December 31st. Everything we call a civilization fits into a sliver so thin it almost disappears. For most of that year, Earth was already busy. Oceans formed, mountains rose and wore down again. Life emerged, struggled, adapted, and transformed itself again and again, long before anyone was around to notice. And this is where a quiet, unsettling question begins to take shape. Not shouted, not dramatic, just gently persistent. What if Earth had hosted an advanced civilization before us? Not thousands of years ago, not even hundreds of thousands, but millions of years ago. Not aliens, not mythic beings, just another intelligence that rose, organized itself, altered its environment, and then vanished so completely that almost nothing obvious remained. At first, that idea can sound like science fiction. We're used to associating ancient advanced civilizations with lost continents, sunken cities, or dramatic ruins waiting to be rediscovered. But that's because our sense of ancient is still very young by geological standards. We picture stone structures, weathered statues, half-buried temples. All of those exist within a blink of Earth's deep time. Millions of years is not a blink, it's an eraser. Earth is exceptionally good at forgetting. Mountains crumble grain by grain, rivers grind stone into sand, tectonic plates slide, collide and sink back into the mantle, carrying entire landscapes with them. Oceans open and close, glaciers bulldoze continents, volcanic flows bury everything in their path. Given enough time, even the most durable structures become indistinguishable from the rock around them. Not broken, not hidden, simply gone. So when we ask whether a civilization could have existed long before us, the real question isn't why we haven't found its cities. The question is whether we would expect to find anything at all. Our assumptions are shaped by our own brief presence. We've been industrial for only a few centuries. Already we've left marks that feel permanent, plastics in sediments, chemical signatures in the atmosphere, artificial materials layered into the crust. It's tempting to imagine these traces lasting forever, like a signature carved into stone. But stone doesn't last forever either. Over millions of years, even the planet's memory smooths itself out. This leads to a strange kind of humility. We like to think of ourselves as the first to ask big questions, the first to reshape the planet in meaningful ways, the first to stand back and wonder about deep time. But Earth doesn't advertise firsts. It doesn't label beginnings or endings. It just keeps moving. Consider how we define advanced. Usually we mean technology, energy use, infrastructure, communication. But those definitions are shaped by our own path. Another civilization, even one capable of complex organization and scientific understanding, might have developed along very different lines. It might not have built sprawling cities of concrete and steel. It might not have relied on fossil fuels. It might not have produced waste that fossilizes neatly into future rock layers. Intelligence doesn't come with a required aesthetic. Even our own civilization is more fragile than it feels. Without constant maintenance, buildings decay quickly, roads crack, metal corrodes. Within a few thousand years, much of what we build would be unrecognizable. Stretch that timeline to 1,000,000 years, and the difference between ruins and natural formations becomes meaningless. There's also the issue of where we look. We tend to search for signs of past civilizations on the surface, because that's where ours exists. But Earth's surface is a moving target. Most land that existed millions of years ago is either deeply buried, subducted into the mantle, or transformed beyond recognition. The oldest exposed rocks on Earth are rare exceptions, not the rule. Expecting to find neat evidence of a lost civilization is a bit like expecting yesterday's footprints to survive a tidal wave. This doesn't mean such a civilization existed. It means the absence of evidence is less informative than we often assume. Geological time doesn't preserve history evenly. It preserves accidents, unusual conditions, rare alignments of stability and burial. Fossils themselves are astonishingly uncommon when you consider how much life has existed. The fact that we find any at all is remarkable. Expecting cultural artifacts to fare better is optimistic at best. There's another layer to this idea that feels even more unsettling. If Earth could erase a civilization so completely, what does that say about us? Not in a dramatic sense, not as a warning, but as a reminder of scale. Our story feels central because we're inside it. From the planet's perspective, we are one episode in a long series still unfolding, not yet resolved. This isn't meant to diminish human achievement or curiosity. In fact, it does the opposite. It places us into a much larger context, one where intelligence itself might be a recurring experiment rather than a singular event. Earth has had billions of years to run variations on life. Given enough time, complexity tends to emerge. Given enough complexity, awareness sometimes follows. And awareness doesn't announce itself to geology. If an earlier civilization existed, it might not have looked outward the way we do. It might not have launched satellites or etched its presence into orbit. It might have remained planetary, or even deeply integrated with natural systems in ways that left fewer scars. Advancement doesn't always mean expansion. Sometimes it means efficiency. Sometimes it means restraint. There's also the possibility that such a civilization was brief. Not brief in human terms, but brief in geological ones. A few 100,000 years is a long time to live, build, think, and change. It's also almost nothing to a planet that measures time in mountain ranges and ocean basins. Earth has seen entire species flourish and vanish, without leaving more than a thin chemical trace. When we imagine a lost civilization, we often imagine catastrophe. A sudden end, fire, flood, impact. But slow endings are far more common. Climate shifts, resource depletion, gradual decline. Societies don't always fall with a bang. Sometimes they simply thin out, fragment and dissolve back into ecosystems that keep going without them. And ecosystems are very good at reclaiming space. Forests don't remember cities. They grow over them. Oceans don't preserve coastlines, they redraw them. Over time, the difference between built and grown blurs until it no longer matters. So here we are, asking a question that feels speculative but is grounded in something very real. Earth's age, Earth's processes, Earth's indifference to narrative closure. Whether or not an advanced civilization existed before us, the fact that it could have without leaving obvious traces is itself revealing. It reminds us that history at planetary scale is not a story with chapters and clean transitions. It's a continuous surface, folded and refolded, with most details pressed out of view. So as you settle in, letting the weight of the day ease a little, keep that image in mind. A very old planet, many layers, long stretches of silence, and somewhere within that silence, the possibility that Earth has hosted more stories than it ever tells us directly. At some point, numbers stop behaving like numbers and start behaving like fog. That's usually where deep time lives. We can say millions of years easily enough, the way we say a long day or a long drive, without really feeling what that stretch contains. The phrase sounds impressive, but it stays distant, floating somewhere outside ordinary experience. It doesn't tug at memory or emotion. It doesn't sit in the body the way a childhood summer or a sleepless night does. Most of the time, deep time remains safely abstract, a backdrop rather than something we inhabit. But every so often, that abstraction slips. Not all at once, not dramatically, but quietly, the way a room feels different when the lights dim. Suddenly, millions of years stop feeling like a math problem and start feeling like a presence. Something vast, slow, and very real. This usually happens when we try to anchor those numbers to something familiar. Take your own life, for instance. However old you are, imagine every year you've lived as a single page in a book. Now imagine stacking those pages neatly on a table. Even a long human life would barely form a thin booklet. You could flip through it in seconds. The memories would feel dense and important to you, but physically the stack would be modest. Now imagine doing that for 10,000 years. The stack grows taller, heavier, harder to lift. That's already far beyond recorded history for most of the planet. Keep going. 100,000 years. 1,000,000. At some point the stack becomes unmanageable. You're no longer flipping pages. You're staring at a tower that fills the room, then the building, then the horizon. And Earth doesn't measure time in books. It measures time in pressure. Rocks do not hurry. They form grain by grain, layer by layer, under conditions that would crush most things we recognize as solid. A centimetre of sediment might represent thousands of years. A mountain range might represent tens of millions. When you stand on exposed rock, you're not standing on a surface in the way you stand on a floor. You're standing on the visible edge of a process that has been unfolding longer than complex life has existed. This is usually where the feeling shifts. When you realise that the ground beneath you is not a static platform but a slow-moving archive, deep time begins to lose its abstraction. It becomes tactile, heavy, present. Consider a fossil, not as a museum object behind glass, but as a moment that failed to disappear. A leaf pressed into mud, a shell buried just right, a bone covered quickly enough to escape decay. Fossils are not common. They are exceptions. They represent circumstances where time hesitated instead of erasing. Most living things do not leave fossils. Most moments do not leave traces. The fossil record is not a complete story. It's a scattered sampling of what managed to survive a very efficient cleanup process. Now stretch that understanding forward. If even biological life leaves so few reliable records, what chance does culture have? Culture is light. It moves quickly. It depends on structures, habits, and materials that weather poorly. Wood rots, metal oxidizes, concrete cracks. Given enough time, even the most ambitious constructions lose their edges, then their shapes, then their identities. Deep time doesn't just blur details, it actively rearranges the stage. Continents drift at the speed fingernails grow, which feels slow until you give it millions of years to work with. Oceans open where land once stood. Mountain ranges collapse into plains. What was once the surface sinks kilometers below ground, subjected to heat and pressure that erase all recognizable features. Entire regions of Earth's crust are recycled, melted, and transformed into something new. The planet is not a static archive. It's a system that edits itself continuously. This is the moment where the idea of an earlier advanced civilization starts to feel less fantastical and more quietly unsettling. Not because such a civilization suddenly feels likely, but because the reasons we expect to find evidence begin to weaken. Our expectations are shaped by short timelines. We imagine ruins because ruins are what a few thousand years produce. We imagine artifacts because artifacts are what survive human-scale neglect. Deep time doesn't neglect, it processes. There's also a subtle bias in how we imagine advancement. We picture height, permanence, visibility, towers, monuments, networks that span continents, but those are reflections of our priorities and our materials. Another intelligence, arising under different conditions, might optimize for things that leave even fewer traces. Efficiency instead of expansion. Integration instead of dominance. Knowledge passed biologically or behaviorally rather than stored externally. None of those choices would announce themselves to geology. Even our own era, for all its activity, might compress into a surprisingly thin signal over millions of years. A narrow band of unusual chemistry, a brief spike in temperature, a scattering of materials that only stand out if you know exactly where and how to look. Without context, those signals might not look like evidence of intelligence at all. They might look like noise. When deep time stops feeling abstract, it often brings a sense of discomfort, not because it's threatening, but because it reframes importance. We are used to being central to our stories. Deep time does not acknowledge centers, it acknowledges duration. Things that last shape the record, things that don't are smoothed away. This is not an argument for insignificance, it's an argument for proportion. There's something grounding about realizing that Earth has hosted entire worlds that no longer exist in any meaningful sense. Not just species, but climates, coastlines, atmospheric compositions. There were times when the sky itself would have looked unfamiliar. Times when oxygen was scarce or overwhelming. Times when life thrived in forms that no longer have living descendants. All of that happened without witnesses capable of reflection. And yet it mattered, because it shaped what came after. If an earlier civilization existed, it would have lived inside one of those vanished worlds. Its environment would not have been our environment. Its challenges would not have been our challenges. Its disappearance would not necessarily resemble collapse as we imagine it. It might have been gradual, ecological, or simply absorbed into changing conditions. Deep time is especially good at dissolving edges. It doesn't preserve beginnings and endings cleanly. It blends them. The rise of a civilization and its decline might compress into a single indistinct layer, indistinguishable from natural variation unless examined with extraordinary care. This is where the question shifts again. It's no longer, did this happen, but what would it even mean to know? Our tools are designed to study what remains. Deep time ensures that most things do not. When scientists study Earth's distant past, they rely on indirect clues, isotopes, ratios, patterns that suggest processes rather than events. The further back you go, the more interpretation replaces observation. Certainty becomes statistical. Stories become models. Confidence becomes provisional. This isn't a weakness of science. It's an honest reflection of the medium it works with. Geology does not read like history. It reads like weathered handwriting, smudged and incomplete, where entire paragraphs are missing and others overlap. We fill gaps carefully, aware that any reconstruction is temporary. subject to revision when a new layer is uncovered or a better method emerges. That awareness is important. It teaches restraint. It encourages questions without demanding closure. Deep time rewards patience more than answers. There's also a psychological shift that happens when you sit with these scales long enough. Personal urgency softens, not disappears, but relaxes. The worries of a single day don't vanish, but they lose some of their sharpness when placed against a planet that has outlasted ice ages, mass extinctions, and radical transformations of life itself. Deep time doesn't solve problems, but it changes how tightly we grip them. This matters for the idea we're exploring, because speculation without urgency behaves differently. It becomes contemplative rather than assertive. We're not trying to prove that Earth once hosted an advanced civilization. We're allowing space for the idea because deep time makes space unavoidable. When time stretches far enough, rarity behaves differently. Events that seem improbable over short spans become almost expected over long ones. Life emerged on Earth relatively quickly after conditions allowed it. Intelligence emerged at least once. Given enough time and opportunity, it's not unreasonable to wonder whether complexity might arise more than once, even if it takes very different forms each time. Still, deep time does not guarantee repetition. It only permits it. What it certainly does is undermine the assumption that we would recognize all prior intelligence if it existed. Recognition depends on familiarity. Deep time ensures unfamiliarity. As we move forward from here, the abstraction will continue to thin. Not because the numbers get smaller, but because the implications grow clearer. Earth is old in a way that resists storytelling. Its memory is selective. Its surface is temporary. Its history is mostly inaccessible to creatures who have existed for only a moment by its standards. This doesn't close the question. It opens it carefully, without forcing it into certainty. It invites us to think not in terms of discovery or revelation, but in terms of limits. What can be known? What can be inferred? What might remain permanently beyond reach? And in that space between what we expect and what deep time allows, the idea of earlier civilization stops feeling like fantasy and starts feeling like a quiet reminder. The planet we live on has had more time than we usually remember to imagine possibilities of its own. There is a particular kind of quiet that only appears when you look far enough back. It is not the absence of sound, but the absence of detail. A silence that doesn't feel empty so much as unfinished. This is the silence that fills Earth's earliest pages, the stretches of time where the planet was already busy being itself, but left behind very little that speaks clearly to us now. When we imagine the deep past, it's tempting to picture a continuous record, like a book with yellowed pages that can still be read if you're careful. That isn't how Earth works. Its history is not bound neatly. Pages are torn out, overwritten, melted down, and reused. Entire volumes are lost without ceremony. What remains is fragmentary, uneven, and often frustratingly quiet. The earliest chapters of Earth's story are not missing because nothing happened. They are missing because so much happened. In the first few billion years of the planet's existence, Earth was anything but stable. The surface was in constant motion. Heat flowed freely from the interior. Impacts were frequent. The crust was thinner, weaker, more easily recycled. Conditions that allow for long-term preservation were rare and temporary. The planet was young, energetic, and indifferent to keeping records. Even today, preservation is selective. A footprint in wet sand can vanish in minutes. A fallen tree can disappear in decades. A city can erode into rubble in centuries. Stretch that process over millions of years, and the list of things that survive becomes astonishingly short. Now imagine that same erasing machinery operating on a planet that was far more volatile than it is now. This is why Earth's earliest pages feel silent. Not because they were uneventful, but because the mechanisms that preserve information had not yet gained the upper hand. The oldest rocks we can study are rare survivors. They're exceptions that endured through extraordinary circumstances, They tend to be heavily altered, their original features blurred by pressure and heat. What they tell us comes in hints rather than narratives. Chemical ratios, mineral alignments, subtle signatures that suggest conditions rather than events. There are no photographs of early Earth, no recordings, no direct witnesses. Everything we know is reconstructed from leftovers that were never meant to last. This silence becomes especially strange when you consider how much time it covers. Hundreds of millions of years pass with little more than scattered clues. Life emerges somewhere in that quiet, but even that moment leaves only indirect evidence. Simple organisms appear, persist and evolve long before anything recognizable to us walks, thinks or builds. And if intelligence arose during one of those long stretches, it would have done so under conditions very different from our own. The farther back you go, the less familiar the world becomes. Atmospheres shift. Oceans change chemistry. Continents do not resemble modern maps. The rules of survival are not the same. Any civilization that developed in such an environment would not only be distant in time, but alien in context, even if it shared our planet. This is an important distinction. When we look for past civilizations, we tend to look for ourselves reflected backward. Familiar shapes, familiar materials, familiar priorities. Deep time does not reward that approach. It replaces familiarity with distortion. Earth's silence is not uniform either. It comes in layers. Some periods speak more loudly than others. Mass extinctions leave signatures. Climate shifts leave traces. Large-scale changes sometimes carve sharp lines into the record. But quieter stretches, even those that lasted for tens of millions of years, can blend into near invisibility. That blending is part of the problem. Suppose a civilization rose slowly, adapted carefully and declined without catastrophe. Suppose it never triggered a dramatic global event. No sudden atmospheric spike. No massive die-off. No abrupt geological signal. From Earth's perspective, that civilization might register as background noise, indistinguishable from natural variation. This is not speculation layered on top of speculation. It's a reflection of how incomplete the record already is for things we know happened. There are entire ecosystems that left almost no trace. Soft-bodied organisms dominate certain eras but fossilize poorly. Vast populations lived and died without leaving anything recognizable. We infer their existence only because later life depends on what they must have done. Earth remembers outcomes better than processes. This creates a strange asymmetry. We are very good at seeing consequences. We are much worse at seeing the paths that led to them. The earliest pages of Earth's story are filled with consequences whose origins we can only guess at. When we encounter this silence, it's tempting to fill it with certainty, to assume that what we don't see did not exist, that absence is equivalent to non-existence. On human timescales, that's often a reasonable assumption. On geological timescales, it's risky. Silence in the record often means erasure, not emptiness. The planet has a habit of smoothing itself. Sharp edges disappear, unusual patterns fade. Over time, complexity collapses into averages. A detailed city and an unremarkable outcrop can both end up as indistinguishable sediment, given enough cycles of erosion and burial. This smoothing effect is relentless. It doesn't target civilizations, it targets everything. Even the things we consider permanent are only temporarily resistant. Stone monuments weather, metals corrode, synthetic materials degrade. Some may last longer than others, but none are immune to the combined forces of chemistry, pressure, heat, and time. The strange silence of Earth's earliest pages is, in part, the sound of those forces doing their work. There is also a scale problem that often goes unnoticed. We search for evidence in places we can reach. Exposed rock, accessible formations, shallow cores. But most of Earth's history is locked away deep underground or has been destroyed entirely. The crust we can examine is a thin, biased sample. Large portions of ancient seafloor are gone. subducted into the mantle and melted beyond recognition. Entire continents have been reassembled multiple times. What remains at the surface is not representative of what once existed. It is what happened to survive. Imagine trying to reconstruct the history of a library after most of its books have been burned, the shelves rearranged, and the floor replaced several times. The few pages you find under the rubble are not going to tell a complete story. They might not even tell the most important one. This is the challenge deep time presents. It doesn't hide information maliciously, it simply refuses to preserve it evenly. When we apply this understanding to the idea of an earlier advanced civilization, the silence becomes less mysterious and more expected. If such a civilization existed millions of years ago, it would have had to contend not only with its own survival, but with a planet that does not prioritize memory. The silence is not proof, it is context. There's another layer to this quiet that feels almost philosophical. Earth does not narrate. It does not label significance. It does not differentiate between natural and intentional change in ways that are obvious to us. From the planet's perspective, a forest spreading and a city spreading are both rearrangements of matter. Over long enough spans, intention leaves little fingerprint. This challenges how we think about intelligence itself. We often define intelligence by its outputs, tools, structures, systems. But intelligence can also be subtle. It can express itself through behavior, adaptation, and decision-making that leaves no durable artifacts. Even within our own species, not all cultures build in ways that last. Nomadic societies, oral traditions, ephemeral architecture, these can persist for thousands of years without leaving the kinds of remains that catch the eye of archaeology. Multiply that by geological time, and their trace approaches zero. The silence deepens. Earth's earliest pages are not just quiet, they are selective. They speak loudly about some things and whisper about others. They tell us about impacts, chemistry, and tectonics more readily than they tell us about organisation, awareness, or intention. This doesn't mean those things weren't there. It means they were not favoured by the recording system. When you sit with this silence long enough, it begins to change how questions feel. The urge to demand answers softens. The expectation of discovery gives way to an appreciation of limits. Some things may remain unknowable, not because we lack intelligence, but because the medium we're reading from is incomplete by design. This is not a failure of curiosity, it's an expansion of it. Instead of asking, where are the ruins? The question becomes, what kinds of traces could survive? Instead of assuming absence implies impossibility, we begin to ask what kinds of existence leave no durable mark. The silence invites that shift. The earliest pages of Earth's story are not blank, they are overwritten. Their silence is not empty, it is layered, compressed, and patient. And as we move on, that patience will become central to understanding why certain questions remain open, not because they are foolish, but because the planet itself has had so much time to forget. At some point, often without realizing it, we begin to treat our own arrival as a starting line. Not consciously, not out of arrogance in most cases, but out of habit. We grow up learning timelines that place humanity at the end of a long build-up, the latest and most complex result of billions of years of gradual change. There is nothing wrong with that picture on its own. It is accurate as far as it goes, but quietly, almost imperceptibly, that picture hardens into an assumption. We begin to feel, rather than reason, that we must be the first to cross certain thresholds, the first to think this way, the first to organise matter on this scale, the first to look back at Earth and wonder what came before. That feeling is powerful, and it shapes how we interpret silence. When we look into deep time and see no obvious evidence of earlier advanced civilizations, the default conclusion is simple and comforting. There were none. We are early. We are unique. The planet waited a very long time for us. This conclusion feels natural because it aligns neatly with the stories we tell ourselves about progress, discovery, and human exceptionalism. It also spares us from wrestling with a more complicated idea, that Earth's history might be richer, messier, and less centred on us than we like to imagine. The assumption that we are the first is rarely stated outright. It operates quietly in the background, shaping questions before they are even asked. Research focuses on the emergence of intelligence as a single, linear arc leading to us. Speculation about earlier intelligence is often dismissed not because it has been disproven, but because it feels unnecessary. Why complicate the story when the simplest explanation works well enough? But simplicity is not the same as inevitability. One reason we assume we are the first is that we confuse visibility with novelty. Our civilization is visible. It has reshaped landscapes, altered atmospheric chemistry, and sent machines beyond Earth itself. From within our moment, this feels unprecedented. It feels like a sharp break from everything that came before. But that impression is shaped by proximity. We are living inside the change, so it feels louder than any past change whose echoes have faded. There is also a psychological component that is difficult to separate from cultural influence. Many societies, particularly industrial ones, are steeped in narratives of firsts. First flight, first space mission, first computer, first to split the atom. These milestones are real and meaningful, but they reinforce a worldview where history is a ladder, and we are always climbing higher than anyone before us. In that framework, the idea of an earlier advanced civilization feels like a contradiction rather than a possibility. Another reason the assumption persists is that we tend to define advanced in ways that conveniently include us. Technological complexity, large-scale infrastructure, global coordination, energy-intensive systems. These criteria reflect our own development path. They are not neutral. They privilege certain outcomes over others. If intelligence took a different route in the past, one that did not culminate in sprawling cities or industrial-scale production, we might not recognize it as advanced at all. This is not a flaw in reasoning so much as a limitation of perspective. Consider how easily we overlook complexity that does not announce itself loudly. Ecosystems manage energy flows with astonishing efficiency. Social insects coordinate millions of individuals without centralized control. Biological systems solve problems that our most advanced technologies still struggle to replicate. We acknowledge these forms of sophistication, but we rarely place them on the same conceptual level as human technological achievement. We categorize them as natural rather than intelligent, even when they display remarkable organization. That distinction matters. If we reserve the label of intelligence only for things that resemble us closely enough, then we have already narrowed the field before the search begins. There is also the matter of narrative comfort. Being the first carries a certain weight of purpose. It frames humanity as a culmination, a turning point, a species that finally became aware of the universe. That story is emotionally satisfying. It places us at the centre without needing to say so explicitly. Letting go of that story does not diminish us, but it does require a kind of humility that is not always encouraged. Deep time makes that humility unavoidable if we let it. Earth has hosted life for billions of years. For most of that time, life was microscopic. Then it wasn't. Then it diversified, experimented, and filled every available niche. Extinctions reset the board more than once. Each time, life found new pathways forward. From that perspective, intelligence does not look like an inevitability or a singular achievement. It looks like one possible outcome among many, contingent on circumstances that could plausibly arise more than once. Yet we resist that idea. We assume intelligence is fragile, rare, and easily extinguished, except when it comes to ourselves. We see our survival as proof of uniqueness rather than luck, timing, or temporary stability. The assumption that we are the first also relies heavily on the idea that Earth's past has been thoroughly examined. In reality, we have sampled only a fraction of the planet's history. Most of what we know comes from accessible regions, well-preserved formations, and periods that left clearer signals. Large gaps remain, especially in the distant past. Those gaps are not empty by default. They are unknown. Unknowns make people uneasy. They invite speculation, which is often viewed with suspicion in scientific contexts, not because speculation is inherently wrong, but because it can be misused. Over time, this caution can harden into dismissal. Questions that cannot be answered cleanly are quietly set aside. Not forbidden, just unfashionable. This creates a feedback loop. We assume we are the first because we do not look for alternatives seriously, and we do not look for alternatives seriously because we assume we are the first. There is also an anthropological habit at play. Humans tend to see themselves as endpoints. Many cultures have myths that place humanity at the centre of creation, or at the peak of a sequence. Even secular narratives often replace divine intention with technological destiny. The language changes, but the structure remains. We arrived last, therefore we are the most advanced. Deep time does not support that structure. It does not have endpoints, only transitions. When we look at Earth through a geological lens, the idea of first becomes slippery. First according to what metric? First to use tools? Many species do that. First to modify environments? Life has been doing that since oxygen-producing bacteria reshaped the atmosphere. First to store information externally. DNA already does that, and ecosystems encode memory in their structure. If we narrow the definition further to conscious, reflective intelligence capable of complex culture, the question becomes harder, not easier. Consciousness leaves no direct fossil record. Culture leaves fragile traces. Reflection leaves none at all unless it is recorded in durable materials, and even those materials are temporary on geological scales. So the assumption that we are the first is not based on strong evidence. It is based on familiarity. Familiarity feels like certainty when nothing challenges it. Another subtle reason we assume we are the first is that imagining otherwise forces us to confront our own impermanence. If Earth could host an advanced civilization before us and erase it almost completely, then our own long-term survival feels less guaranteed. Not tomorrow, not in any immediate sense, but eventually. That thought is unsettling, even when approached calmly. It is easier to believe that intelligence emerged once, late, and now carries the responsibility of stewardship forward indefinitely. It is harder to accept that intelligence might be a recurring phenomenon, subject to the same forces of rise, adaptation, and decline as everything else on the planet. None of this requires catastrophe. Decline does not need drama. Over millions of years, even stable systems drift. Climate changes, continents rearrange, resources shift. What works in one era becomes irrelevant in another. Adaptation does not always mean persistence. If we are honest, much of our confidence in being the first rests on how short our frame of reference is. Recorded history covers a few thousand years. Archaeology extends that by an order of magnitude. Beyond that, we rely on proxies and models. The deeper we go, the more tentative our conclusions become. Yet emotionally, we often treat those tentative conclusions as final. The assumption also persists because it is rarely tested directly. We do not design experiments to detect past intelligence over millions of years. We design them to study climate, tectonics, biology, and chemistry. Intelligence is not expected, so it is not sought in a systematic way. Absence of targeted investigation then becomes absence of evidence, which quietly reinforces the original assumption. This is not a criticism of science. Science works by asking precise questions. But it is worth noticing how the questions themselves are shaped by prior beliefs. When we step back from those beliefs, the picture changes slightly. Not dramatically, not enough to claim certainty, but enough to soften the edges of the assumption. Enough to admit that being first is not something we can verify with confidence. As we move forward, The goal is not to replace one assumption with another. It is to recognize how assumptions form, why they feel so convincing, and where they might be misleading us. The idea that we are the first is not wrong by default. It is simply unproven, resting on a foundation that becomes less solid the further back we look. Earth's history is long. Its memory is incomplete. Intelligence, if it arises, does not guarantee visibility. Holding all of that together leads to a quieter stance, one where we acknowledge our achievements without insisting on uniqueness, one where curiosity remains open rather than defensive, one where the silence of the past is not treated as an answer, but as an invitation to think more carefully about what we expect to hear. Instead of beginning with cities, tools, or machines, it helps to pause and ask a quieter question. What do we actually mean when we say the word civilization? Not the textbook definition, not the checklist version, but the underlying idea we carry with us when we imagine one. Most of the time, without noticing, we load that word with assumptions that come from our own experience. Dense populations, permanent settlements, written language, large-scale construction, layers of infrastructure visible even from space. Those features feel obvious because they surround us. They feel natural because they describe us. But none of them are required by nature. Civilization, at its most basic level, is not a skyline or a power grid. It is a pattern of coordination. It is a way a group of intelligent beings organizes itself across time. That organization can be loud or quiet. It can carve its presence into stone, or it can pass almost invisibly through generations. The planet does not distinguish between the two. It only responds to energy, matter, and time. When we define civilization too rigidly, we narrow the range of possibilities before we even start looking. We train ourselves to recognize only what looks familiar, and familiarity is a poor guide when dealing with deep time. Earth has hosted environments, chemistries, and life forms that no longer exist. Expecting intelligence in those contexts to resemble ours is a leap that feels intuitive but rests on very thin ground. Consider how much of what we call civilization is not physical at all. Language lives in minds before it lives on surfaces. Social rules exist in behaviour long before they exist in writing. Knowledge can be stored in memory, tradition, and practice without ever being etched into durable materials. Even today, there are societies whose complexity far exceeds what their physical remains might suggest. Remove their people, give the planet a few thousand years, and much of their sophistication would dissolve without a trace. Now extend that idea by several orders of magnitude. Over millions of years, even robust physical structures lose coherence. Over tens of millions, they vanish entirely. But non-physical systems vanish much faster. Customs, values, decision-making frameworks, and shared understanding leave no geological fingerprints. They are real, powerful, and influential while they exist, and then they're gone. If an earlier civilization developed in a way that emphasized stability over expansion, balance over extraction, or continuity over growth, it might have left behind very little that we would identify as advanced. Its success, in fact, might correlate with its invisibility. This runs counter to how we usually think about progress. In our story, advancement is cumulative and outward-facing. Each generation builds on the last, leaving more behind. More infrastructure, more alteration, more markers of presence. But that model reflects a specific path, not a universal rule. There are many ways to be complex. Biological systems demonstrate this constantly. A rainforest manages energy flows, resource distribution, resilience, and adaptation without centralized planning or durable architecture. It does so through feedback loops, cooperation, competition, and redundancy. If intelligence emerged within such a system, it might express itself through refinement rather than replacement, through guidance rather than domination. From a geological perspective, that kind of civilization would be almost silent. The softness in this definition is not vagueness, It is flexibility. It allows for intelligence that does not announce itself through scars. It allows for organisation that adapts to planetary limits rather than pushing against them. It allows for the possibility that advancement does not always mean bigger, faster, or more visible. This matters because the absence of visible ruins is often treated as decisive evidence. No cities, no machines, no roads, therefore no civilization. But that logic assumes that all civilizations must produce ruins in the first place. Deep time does not support that assumption. Even our own civilization, if stripped of its current materials, would leave a surprisingly ambiguous record. Plastics degrade, metals corrode, concrete fractures, and is eventually reabsorbed into sediment. Some chemical signatures might linger, but only if future observers knew exactly what to look for. Without context, those signals might be misinterpreted as natural anomalies. Now imagine a civilization that never relied heavily on long-lasting synthetic materials, one that used organic substances, biodegradable structures, or technologies designed to fade back into ecosystems once their purpose was served. From a human perspective, that might seem inefficient. From a planetary perspective, it would be remarkably clean. The softer definition also challenges the idea that civilization must always scale up. We often equate advancement with size, larger populations, larger networks, larger impact, but scale is not synonymous with intelligence. In some cases, scaling down is more difficult and more impressive. Maintaining stability across smaller distributed populations over long periods requires sophisticated coordination, even if it leaves little physical evidence. Time amplifies this effect. A civilization that lasts 1 million years without destabilizing its environment would, paradoxically, leave fewer traces than one that burns brightly and collapses within a few thousand. Longevity and visibility do not always align. This creates an uncomfortable inversion of expectations. The civilizations we are most likely to detect in deep time may be the least successful ones, the ones that altered the planet abruptly, triggered noticeable changes, or left behind stubborn materials that resisted decay. Quiet success does not fossilize well. When we loosen our definition of civilization, we also loosen the emotional stakes of the question. It becomes less about claiming a hidden past and more about understanding how intelligence might interact with a planet over very long durations. It shifts attention away from monuments and toward processes. Processes are easier for Earth to erase. There is another reason our definitions tend to be rigid. They help us draw boundaries: civilization versus nature, culture versus environment. Those distinctions are useful for organizing thought, but they are not absolute. Over deep time, they blur. Cities crumble into soil, tools become minerals, human influence becomes just another layer. If an earlier intelligence blurred those boundaries intentionally, seeing itself as part of Earth rather than separate from it, its footprint might be indistinguishable from natural change after enough time passed. This does not require idealization. It does not require imagining a perfect, harmonious society. It simply requires recognizing that not all paths of development converge on the same outcomes. Our own civilization is shaped by specific contingencies: readily accessible fossil fuels, a relatively stable climate during key developmental periods, geological configurations that allowed agriculture to spread. These factors are not guaranteed in every era. An intelligence arising under different constraints would make different choices, even if it solved similar problems. When we assume that civilization must look like ours to count, we project those contingencies backward as necessities. Deep time resists that projection. Softening the definition also helps explain why the idea of prior civilizations feels both intriguing and slippery. We want something concrete, something we can point to and say, there it is. But the most plausible forms of ancient intelligence may not cooperate with that desire. They may have existed primarily in behavior rather than artifacts, in relationships rather than structures. in knowledge systems passed biologically, culturally, or epigenetically rather than stored externally. All of those are real. All of them matter. None of them are durable on geological scales. Earth does not reward subtlety with memory. There is a tendency, especially when discussing speculative ideas, to swing between extremes. Either a civilization must be grand, obvious, and dramatic, or it must be dismissed entirely. The softer definition avoids that trap. It allows for gradation, for partial advancement, for intelligence that rises, adapts, and perhaps fades without ever reaching the thresholds we associate with modern industry. It also aligns more closely with how evolution actually works. Evolution does not aim for endpoints. It explores local solutions. It tries what works for now. Intelligence, if it arises, is one such solution. It is not guaranteed to persist. It is not guaranteed to escalate. Seen this way, the emergence of intelligence on Earth does not feel like a singular miracle or an inevitable march toward us. It feels like one expression among many, shaped by context, chance, and constraint. That framing changes the emotional tone of the question. Instead of asking whether we have been robbed of a forgotten golden age, we ask how many forms of intelligence might be compatible with a living planet. Instead of searching for proof of predecessors, we explore the limits of what proof could look like. As this perspective settles in, the silence of deep time feels less accusatory. It stops sounding like a challenge to be overcome and starts sounding like a reminder. Earth does not preserve meaning. It preserves matter, and even that only temporarily. If earlier civilizations existed, they would have lived real lives. They would have solved problems, faced uncertainties, and made choices within their moment. Their absence from the present does not negate their existence, any more than the absence of countless extinct species negates theirs. We know life can vanish completely while leaving only the faintest hints. Entire branches of the evolutionary tree are known from a handful of fragments. Intelligence, especially if it did not externalize itself aggressively, could disappear even more thoroughly. This does not mean we should assume such civilizations existed. It means we should be careful about assuming they did not, based solely on definitions that privilege visibility and familiarity. As we continue, the focus will narrow slightly. The question will move from definitions to mechanisms. How exactly does Earth erase information? What survives longest, and why? What kinds of traces are almost guaranteed to vanish? These are practical questions grounded in geology, chemistry, and physics. The softer definition of civilization prepares us for those questions by lowering expectations of what detection would even mean. It reminds us that the planet is not obligated to leave behind recognizable stories, and it gently suggests that intelligence, if it has appeared before, may have done so in ways that make our search feel like listening for a whisper in a room that has been echoing for millions of years. Memory feels like something that fades gently, the way a scent lingers in a room after a door closes. Earth does not forget that way. When the planet forgets, it does so through motion, pressure, chemistry, and heat, working steadily and without pause. Forgetting, on geological timescales, is not passive. It is an active process that reshapes, recycles, and eventually dissolves almost everything that exists on the surface. To understand how long Earth takes to forget, it helps to stop thinking in human units entirely. Years, centuries, even millennia are too small to register meaningfully. Earth measures time in cycles that feel almost abstract to us. Cycles of uplift and erosion, burial and exposure, compression and melting. These cycles do not erase information evenly. They blur, fragment, and overwrite it until what remains is stripped of context. Start with erosion, the most familiar and the most underestimated of Earth's erasers. Wind, water, and ice grind landscapes down continuously. Mountains lose height grain by grain. Riverbeds migrate. Coastlines retreat. A single storm can undo years of construction. Given enough repetition, erosion does not leave ruins. It leaves sediment, and sediment does not remember what it once was. Sediment is Earth's filing system, but it is not an organised one. Layers pile up unevenly, compressing what lies beneath. Under pressure, those layers harden into rock. The process preserves shapes only under very specific conditions. Soft materials vanish almost immediately. Harder ones persist longer but still deform, fracture, and eventually lose definition. A structure that stands for centuries can become unrecognisable in tens of thousands of years. Stretch that to millions, and recognition itself becomes unlikely. Burial accelerates forgetting. When material is covered quickly, it is removed from surface processes, but it is not frozen in time. Pressure increases, temperatures rise, chemical reactions continue, minerals recrystallize, original structures warp or dissolve. This is why many ancient rocks no longer resemble their original form. They have been cooked and squeezed until their earlier identity is effectively gone. Then there is tectonics, the slow but relentless rearrangement of Earth's crust. Plates drift, collide, and sink. Entire regions are pulled down into the mantle through subduction, where temperatures and pressures are high enough to erase any remaining trace of surface features. Once that happens, the material is no longer part of the readable record. It has been reset completely. Oceanic crust, where much of Earth's surface area lies, is especially temporary. Most seafloor is younger than 200 million years. Anything that existed on ancient ocean floors has almost certainly been destroyed. If a civilization had developed along coastlines or shallow seas in the distant past, much of its physical footprint could now be deep within the mantle, unrecoverable by any means we currently possess. Forgetting also happens through mixing. Sediments are reworked repeatedly. Rivers carry particles far from their source. Glaciers scrape and redistribute material across continents. Over time, distinct layers blur, boundaries soften, signals weaken. What was once concentrated becomes diluted beyond recognition. This is why Earth's memory is biased. It preserves the unusual, rapid burial, exceptional chemistry, sudden events. Slow, steady activity is harder to detect. A civilization that altered its environment gradually, or maintained equilibrium over long periods, would produce fewer sharp signals than one that disrupted systems abruptly. Chemical forgetting is quieter, but just as thorough. Materials react with their surroundings. Metals oxidize. Organic compounds break down. Even durable substances are not immune. Over millions of years, chemistry nudges everything towards stability. High-energy configurations decay. Complexity collapses into simpler forms. Some people imagine that certain materials like plastics or advanced alloys might serve as permanent markers. In reality, permanence is relative. Plastics fragment and degrade. Metals corrode and diffuse. Given enough time, even the most stubborn materials lose their defining properties. What remains may no longer indicate intentional design. Heat is the ultimate editor. Deep burial raises temperatures enough to reset mineral structures entirely. Metamorphism transforms rock, erasing earlier features while preserving only vague chemical hints. Once rock melts, all previous information is lost. Magma does not remember what it once was. The timescale for these processes varies, but none of them require billions of years to be effective. Significant forgetting can occur in a few million years. Complete erasure may take longer, but Earth has had more than enough time. This matters because human intuition tends to overestimate durability. We live surrounded by objects designed to last longer than we do. Buildings feel solid. Roads feel permanent. Monuments feel timeless. But these impressions are anchored to lifespans measured in decades. Earth operates on a clock where even stone is temporary. Archaeology works because it operates within a narrow window. Tens of thousands of years are enough for some things to survive under favourable conditions. Beyond that window, preservation becomes increasingly rare and increasingly selective. Past a few million years, the odds drop sharply. This does not mean nothing survives. It means survival is accidental. Fossils themselves are not guaranteed. The vast majority of organisms that have ever lived left no fossil record at all. We infer their existence indirectly. Entire lineages are missing. If biological life, which reproduces in enormous numbers, leaves such a sparse record, a civilization with a comparatively small population would fare far worse. Earth forgets quietly, but it forgets thoroughly. There is also the issue of scale relative to detection. Even if traces survive, finding them is another matter. We sample Earth's crust sparsely. Drilling projects cover tiny fractions of the planet. Exposed rock represents a biased selection shaped by uplift and erosion. Many regions remain unexplored or inaccessible. The absence of evidence is magnified by the difficulty of looking in the right place at the right depth. Detection depends on expectation. We look for what we know how to recognize. If traces do not match our expectations, they may go unnoticed or be misclassified as natural anomalies. A subtle chemical signature could be dismissed as background variation. An unusual mineral assemblage might be attributed to unknown geological processes rather than intentional activity. Earth does not label its memories. Interpretation is always required. Forgetting is also uneven across environments. Dry, stable regions preserve more than dynamic ones. Cold slows chemical reactions. Rapid burial protects some materials temporarily. But these conditions shift over time. What is stable in one era may become hostile in another. A preserved record can be exposed, weathered, and erased long after its creation. This dynamic quality makes long-term preservation unreliable, even when conditions initially seem favourable. Earth is not static long enough for certainty. When people imagine earlier civilizations, they often picture a moment of collapse followed by abandonment. In reality, abandonment does not freeze a place in time. Without maintenance, structures degrade quickly. Vegetation takes over. Roots pry apart stone. Microorganisms accelerate decay. Within centuries, signs of occupation soften. Within millennia, they blur. Within millions of years, they vanish. The planet does not need catastrophe to forget. It only needs time. There is something oddly reassuring about this. Earth's capacity to forget is also its capacity to renew. The same processes that erase also create. Sediments form new rock. Subduction fuels volcanism. Volcanism creates new crust. Landscapes emerge, change, and emerge again. Forgetting is part of how the planet stays active. But that renewal comes at the cost of memory. If an earlier advanced civilization existed, Earth would not treat it differently from anything else. Its roads would crumble, its buildings would sink or erode, its tools would corrode, its knowledge, unless encoded biologically or behaviourally, would vanish almost immediately. Over deep time, its presence would dissolve into the background of natural processes. This is why asking how long Earth takes to forget is more useful than asking whether Earth remembers at all. Forgetting begins almost instantly. Complete erasure is gradual but relentless. It also explains why our confidence in being the first should be modest. The planet has had ample opportunity to host, erase, and move on from complex systems without leaving obvious clues. That does not mean it did. It means the record cannot settle the question definitively. As this understanding settles in, the silence of deep time becomes less mysterious. It stops feeling like a missing answer and starts feeling like a predictable outcome. Earth is not a historian. It is a process. Picture a city left unattended not for decades, not even for centuries, but for stretches of time so long that maintenance becomes a meaningless concept. No repairs, no clearing of debris, no effort to keep shapes intact. Rain falls, wind scours, plants push through cracks. Eventually, even the idea of a city dissolves into something closer to terrain. Now stretch that image far beyond imagination, past the patience of stone itself, and you begin to approach the scale at which Earth practices erasure. Erosion and subduction are not dramatic processes in the way explosions or impacts are dramatic. They do not announce themselves loudly. They do not arrive all at once. Instead, they work through repetition. Small forces applied over immense spans of time. A grain removed here. A layer shifted there. A surface weakened until it can no longer hold its shape. This is how Earth clears its slate. Erosion begins at the surface, where civilizations would most likely arise. Water flows downhill, always. It carries particles with it, first the smallest, then larger ones as surfaces weaken. Rivers carve channels not by force alone, but by persistence. Coastlines retreat as waves strike again and again, rearranging sand then stone. Wind lifts dust and sand, scouring exposed surfaces, smoothing sharp edges until they no longer catch the eye. Ice adds weight to the process. Glaciers do not scrape gently. They grind. Entire landscapes are flattened beneath their slow advance. Valleys are reshaped. Bedrock is polished. Anything that once stood upright is pressed down, broken apart and redistributed. When glaciers retreat, they do not restore what was there before. They leave behind a rearranged world. This is not hypothetical. Large portions of modern landscapes have been reset multiple times by ice alone. If structures existed in those regions before glaciation, they did not survive as structures. At best, fragments were scattered and buried. At worst, they were ground into indistinguishable debris. Erosion does not discriminate. It does not target buildings more than hills. It simply follows gradients and weaknesses, but human-made structures often create their own weaknesses. Straight lines crack, right angles fracture, foundations channel water. What we build efficiently is often what erodes fastest once neglect sets in. Burial follows erosion naturally. Material removed from one place accumulates in another. Sediment fills valleys, covers plains, and builds deltas. Over time, these layers compact. What was once at the surface sinks beneath additional weight. Oxygen disappears, pressure increases. The environment shifts from one of exposure to one of transformation. Burial does not preserve intent. It preserves shape temporarily, then alters it. Organic materials break down quickly unless conditions are extraordinary. Metals react with surrounding chemistry. Stone deforms. Over long spans, burial leads not to storage but to conversion. Then comes subduction, the most complete form of erasure Earth performs. Tectonic plates are not static platforms. They move slowly, relentlessly. Where plates converge, one is often forced beneath the other, sliding downward into the mantle. This process consumes surface material entirely. Sediments, rock, and anything embedded within them are carried downward, heated, compressed, and eventually melted. At that point, whatever history they contained is gone. Not hidden, not fragmented. Gone. Subduction zones are vast. Entire ocean basins have been destroyed this way. Continents collide, separate, and collide again over geological time. The surface of Earth is a temporary arrangement atop a dynamic interior. Expecting permanent records on such a surface misunderstands how the planet functions. Oceanic crust is especially vulnerable. It is thinner and denser than continental crust, which makes it more likely to sink. Most ocean floor older than 200 million years has already been recycled. If an earlier civilization developed near ancient coastlines or shallow seas, its physical traces could now be deep within the mantle, beyond any possibility of recovery. Even continental crust, which is more buoyant and longer lived, is not immune. Mountain building events bury vast areas. Heat and pressure alter minerals, faults fracture rock. Over time, recognizable features are distorted beyond identification. The deeper material goes, the less it resembles its origin. What makes erosion and subduction particularly effective is how they work together. Erosion lowers surfaces, feeding sediment into basins, burial compacts and transforms that sediment. Subduction eventually consumes it. This is not a single process, but a system designed in effect to recycle the planet's skin. From Earth's perspective, recycling is maintenance. This is where the idea of art in erasure becomes appropriate, not in a poetic sense, but in a functional one. The planet is remarkably efficient. It does not leave clutter. It does not allow accumulation to proceed unchecked forever. Excess material is redistributed. Old surfaces are replaced. Nothing stays exposed indefinitely. Consider how quickly landscapes change even on human timescales. Coastal cities already struggle with erosion. Rivers migrate across floodplains within decades. Hillsides collapse. Now imagine those processes operating continuously for millions of years, uninterrupted by planning committees or preservation efforts. Civilizations depend on stability. Roads assume the ground will remain where it is. Buildings assume foundations will hold. Infrastructure assumes continuity. Erosion and subduction undermine all of those assumptions eventually. This has implications for how we think about long-term traces. A civilization could exist, adapt, and decline entirely within a window where erosion never pauses. Its remains would be dismantled gradually, not catastrophically. There would be no single layer that says, "Here it was." Instead, there would be a slow dilution of evidence until nothing stood out. There is also the issue of scale. Human structures occupy tiny fractions of the surface compared to natural formations. Even a global civilization covers far less area than oceans, deserts, or mountain ranges. When erosion redistributes material, it mixes human-made fragments with vastly larger volumes of natural sediment. Signals weaken quickly. Detection relies on contrast. Erosion removes contrast. Subduction removes context. Together they create blind spots that are difficult to overstate. We often imagine that extraordinary events leave extraordinary traces. Sometimes they do. Large impacts leave craters. Massive eruptions leave ash layers. But civilizations are not single events. They are processes, distributed, variable, and often subtle in their material expression. Processes are harder to freeze into the geological record. A city collapsing into ruins is not a geological event. It is a transient arrangement of matter returning to a more stable configuration. From the planet's perspective, that transition is unremarkable. Even dramatic human-made structures, if abandoned, are quickly claimed by erosion. Steel rusts, concrete fractures. Reinforced materials fail as the components degrade at different rates. Once water infiltrates, decay accelerates. Once vegetation establishes itself, mechanical disruption increases. Roots are powerful tools of destruction. Erosion also operates chemically. Rainwater is slightly acidic. It dissolves minerals slowly but relentlessly. Over long periods, entire rock formations dissolve and reform. Karst landscapes, shaped by dissolution, swallow caves, structures, and anything else that happens to sit above them. Sinkholes open, surfaces collapse, evidence disappears underground. Subduction completes the process by ensuring that even buried material does not remain accessible indefinitely. Heat resets everything. Atoms rearrange. Memory is not just obscured, it is destroyed. This is why the absence of ancient ruins tells us very little about what might have existed millions of years ago. The planet has systems specifically suited to preventing accumulation. It does not tolerate clutter. It is also why the search for ancient civilizations, if taken seriously, must shift away from expectations of intact structures. The question is not whether erosion and subduction could erase a civilization. They absolutely could. The question is what, if anything, could survive those processes. Some materials resist erosion better than others. Some environments slow decay. But none are permanent. Even the most durable traces become distorted, scattered, and eventually recycled. This does not make the question meaningless. It makes it subtle. The art of erasure lies not in how completely Earth forgets, but in how thoroughly it integrates what it forgets back into itself. There is no landfill of history. There is no archive. There is only reuse. Every grain of sand has a history. Every mineral has been somewhere else before. Earth's surface is not a snapshot. It is a flow. That understanding reframes how we think about time and evidence. We stop expecting clear boundaries and start expecting gradients. We stop looking for moments and start looking for patterns. If an earlier civilization existed, erosion and subduction would not leave behind a clear signature saying, "Here was intelligence." At best, they might leave behind faint anomalies, unusual distributions, chemical imbalances, mineral assemblages that do not quite fit known natural processes. Even those anomalies would not shout. They would whisper, and only to those already listening carefully. This is where humility becomes important. Our tools are powerful, but they are tuned to certain kinds of questions. They are excellent at measuring age, composition, and structure. They are less effective at detecting intent after deep recycling has occurred. Erosion and subduction are not adversaries to knowledge. They are simply doing what they have always done. It is our expectations that need adjustment. The planet does not owe us clarity. Long before bones hardened into stone and shells learned how to leave their outlines behind, Earth was already deciding what it would and would not remember. Fossils feel like reliable storytellers to us, but in reality, they are latecomers. They appear only after a long list of conditions are met, after life has already been living, adapting, and vanishing for vast stretches of time with almost no record at all. For most of Earth's history, fossils were not an option. There were no skeletons to preserve, no shells to imprint, no durable shapes to trap moments in rock. Life existed, but secrecy was the default. This matters more than it first appears. Fossils give us a comforting illusion of continuity. They suggest that if something important happens, it will leave a trace. They reassure us that the past, while incomplete, is at least legible. But fossils are not a neutral record. They are a biased filter that only begins working under specific circumstances. Anything that predates those circumstances exists in a kind of archival darkness. The earliest life on Earth was soft, microscopic and fragile. It did not build skeletons or armour. It did not leave bones behind. It lived, divided, interacted, and died, leaving little more than subtle chemical hints. For billions of years, life reshaped the planet, without leaving anything resembling a fossil in the way we usually think of one. Oxygen filled the atmosphere long before complex organisms appeared, driven by life forms that barely registered in stone. If complexity can reshape a planet without leaving obvious physical remains, then intelligence, if it emerged early enough, would face the same problem. Imagine a world where life had already diversified, where ecosystems were stable, where energy flows were understood intuitively by whatever organisms lived there. Imagine intelligence arising not at the end of that story, but somewhere in its long middle, before skeletons, before shells, before the kinds of structures that fossilize well. Any cities built in such a world would not be competing with fossils for preservation. Fossils would not yet exist as a recording mechanism. Even today, fossilization is rare. The overwhelming majority of organisms that die do not fossilize. They decompose, are eaten, are dissolved, or are scattered. Fossilization requires rapid burial, low oxygen, specific chemistry, and a bit of luck. It is an exception masquerading as a rule. Before those exceptions became possible, Earth's record was even thinner. If cities came before fossils could keep secrets, their disappearance would not be surprising. It would be expected. Cities, as we imagine them, rely on materials that are poorly suited to deep preservation. Wood, fibre, clay, metals, organic composites. Even stone construction, if it existed, would erode and fracture quickly without constant maintenance. Without a fossil record to anchor context, those materials would not stand out after millions of years. They would blend into the background of sediment and altered rock. There is also the question of scale relative to time. A city is large on a human map. It is tiny on a planetary one. Even a global civilization would occupy a thin skin on Earth's surface, a fleeting pattern of rearranged matter. Fossilization captures moments of biological life because life is everywhere. Cities are not. Their footprint is narrow, localized, and temporary. The further back you go, the more unforgiving the conditions become. Early Earth was hotter, volcanism was more active, the crust was thinner, recycling was faster, surfaces were less stable. Anything built on top of that instability would have a hard time leaving a mark that survived. This does not require imagining advanced technology in a modern sense. Even modest construction would face the same fate. Walls collapse, roads crumble, foundations sink. Once materials lose their original arrangement, they lose their identity as artifacts. Fossils help us recognize life because life repeats itself. A shell shape appears again and again across populations. A bone structure is shared by many individuals. Even if most examples vanish, enough survive to reveal a pattern. Civilization does not repeat itself in the same way. It is not a biological structure replicated millions of times. It is a cultural arrangement that may exist only in one place at one time. That makes it fragile in the record. Before fossils became common, Earth's memory relied almost entirely on chemistry. Isotopes, elemental ratios, subtle shifts in composition. These clues can tell us about temperature, atmospheric conditions, and biological activity at large scales. They are not well suited to telling us about social organization, planning, or intelligence. If an early civilization existed, its presence might register as a faint chemical ripple, a localized change in soil composition, a transient alteration in nutrient cycles. Over time, those ripples would be smoothed out, diluted, and overwritten. This is not hypothetical. We already struggle to interpret ancient chemical signals correctly. The further back we go, the more ambiguous they become. Even well-established biological milestones are still debated because the evidence is indirect and incomplete. Now imagine trying to detect intentional activity within that ambiguity. Another complication arises from the way we associate cities with permanence. Modern cities feel durable because they are maintained constantly. When maintenance stops, deterioration accelerates dramatically. Abandoned structures do not freeze in time, they collapse. Water infiltrates. Microorganisms colonize. Plants take root. Insects and animals repurpose materials. Within centuries, a city can become unrecognizable. Within millennia, it can disappear almost entirely. Stretch that process across millions of years, and the distinction between built and natural erodes completely. If cities existed before robust fossilization, their remains would not be preserved as cities. They would be reduced to dispersed fragments, chemically altered, physically distorted, and stripped of context. Without fossils to bracket them in time and environment, those fragments would not announce their origin. They would look like rock. There is also a subtle feedback effect. Once fossilization becomes common, it changes how we interpret the past. We begin to expect preservation. We look for bones, shells, and imprints. We anchor timelines around them. Periods without fossils feel empty by comparison, even though they were not. This creates a skewed sense of history. We overemphasize eras that left clear records and underestimate those that did not. The earliest pages feel quiet not because nothing happened, but because the recording technology was not yet available. Civilization, if it arose early, would suffer from this same invisibility. It would exist in a pre-archival world. Even intelligence itself leaves no direct fossil. Brains decay. Neural activity vanishes instantly. Thought leaves no imprint unless it is externalized in durable form. Without writing, without long-lasting materials, reflection and planning leave nothing behind that geology can capture. We often imagine that intelligence naturally leads to external records, but that assumption is based on our own trajectory. Another intelligence might rely more heavily on memory, teaching, or biological encoding. It might not prioritize storage outside the body. From its perspective, knowledge might be something lived rather than archived. In such a case, the loss of physical structures would mean the loss of almost everything. There is a temptation to argue that any advanced civilization would inevitably create technologies that leave permanent traces. This argument rests on a narrow definition of advancement. It assumes that progress always leads toward greater material complexity and energy use. Deep time offers no guarantee of that. A civilization could reach high levels of understanding while remaining materially light. It could optimize for longevity rather than expansion. It could favor materials that degrade cleanly. It could avoid practices that create persistent waste. None of those choices would be irrational. They would simply be different. If that civilization existed before fossils became reliable storytellers, Earth would have little incentive to remember it. The irony is that fossils themselves are a form of accidental preservation. They were not designed to store information. They happened because certain materials resisted decay under specific conditions. Cities, tools, and infrastructure are not built with geological preservation in mind. They are built for function, comfort, and efficiency within a narrow time frame. Earth does not reward intention. It rewards coincidence. This leads to a reframing of the question. Instead of asking whether cities could exist without fossils noticing, we ask whether fossils are capable of noticing cities at all. The answer, especially in deep time, is often no. The absence of fossils does not mean the absence of activity. It means the absence of favourable recording conditions. Entire eras pass with only chemical whispers left behind. Those whispers tell us life was present, but they do not tell us how it behaved. As we move forward, this realization complicates the search for certainty. It suggests that our best tools for reading the past are blunt instruments when it comes to intelligence. They are excellent at identifying biological structures and environmental shifts. They are not designed to capture organization, intention, or awareness. That does not make the idea of earlier civilizations likely or unlikely on its own. It simply removes one of the most commonly cited objections. The lack of fossils is not a decisive argument, it is a limitation. Earth's early pages were written before fossils learned how to speak clearly. Anything that existed then would have lived in a world that did not preserve stories well. Cities, if they arose, would not be competing with dinosaurs for attention. They would be competing with entropy, erosion, and a planet that had not yet developed the habit of keeping souvenirs. This does not end the inquiry, it shifts it. If fossils cannot keep secrets from early life, then what can? What kinds of traces persist longest? What signals might survive even when structures do not? What indirect evidence could hint at organization without relying on familiar markers? Searching the distant past for ruins feels intuitive, almost automatic, because ruins are how we recognize history at human scale. Broken walls, toppled columns, foundations swallowed by soil. These images anchor our sense of what it means for something to have existed and then ended. When we imagine an ancient civilization, our minds reach immediately for stonework and remnants, something solid enough to survive neglect but fragile enough to decay. That instinct works well when we are dealing with thousands of years. It works poorly when we are dealing with millions. The difficulty is not that ruins do not exist. It is that deep time is fundamentally hostile to the concept of ruins as we understand them. Ruins imply partial preservation. They suggest that a structure has lost its function, but retained its form. Deep time does not tolerate that middle ground for very long. It pushes material either toward active participation in surface processes or into transformation so complete that form no longer matters. This is the core problem with looking for ruins in deep time. We are searching for an intermediate state that Earth rarely allows to persist. At human scale, decay feels slow. A building abandoned for a decade still looks like a building. After a century, it may look damaged but recognisable. Even after several centuries, stonework can remain legible. These timescales create an expectation that abandonment leaves behind something interpretable. But geology does not operate within that window. It stretches decay far beyond recognition. The moment maintenance stops, gravity, water and biology take over. Cracks widen. Moisture infiltrates. Microorganisms colonize surfaces. Roots pry materials apart. Metals corrode at different rates than stone. Composite structures fail as their components age unevenly. What we call a ruin is already a temporary phase, not an endpoint. Extend that phase from centuries to millions of years, and it ceases to exist entirely. Deep time does not preserve partial collapse, it completes it. Even stone, which feels like the safest bet for endurance, is not particularly resilient over long spans. Limestone dissolves in weakly acidic rainwater. Sandstone crumbles as cementing minerals break down. Granite fractures along natural weaknesses. Freeze-thaw cycles, chemical weathering, and mechanical stress all work continuously. A block that seems immovable to us is, to Earth, a transient arrangement. Archaeology benefits from working in a narrow temporal corridor, where structures are damaged but not yet destroyed. Outside that corridor, the methods fail. There is no meaningful distinction between an ancient wall and a natural outcrop once sufficient time has passed. Shape alone cannot carry intent indefinitely. Another issue is scale relative to observation. Ruins are only recognisable when they contrast with their surroundings. A standing wall is obvious when it interrupts a flat landscape. A patterned arrangement of stones stands out when nature tends to randomness. Deep time erodes contrast. It smooths patterns. It redistributes material until order dissolves into statistical noise. Looking for ruins millions of years old is like looking for yesterday's footprints after 1,000 storms. The question is not where they are. It is whether they could exist at all. Subsurface ruins fare no better. Burial does not preserve clarity indefinitely. Pressure deforms structures. Chemical alteration changes composition. Heat rearranges minerals. What was once a wall becomes a layer. What was once a foundation becomes a vein. Orientation, alignment, and purpose vanish. There is also the matter of tectonic movement. Landscapes do not stay where they are. Regions uplift, tilt, fold, and sink. What was once horizontal becomes vertical. What was once near the surface ends up kilometres deep. Expecting to recognise ruins after they have been twisted, buried, and partially melted is optimistic in the extreme. The problem deepens when we consider where civilizations are most likely to arise. Historically, they cluster near water, rivers, coasts, fertile plains. These are also the most geologically active and least stable environments over long periods. Rivers migrate, deltas collapse, coastlines flood and retreat. Sediments accumulate rapidly, burying surfaces under meters of material. Stable cratons, the ancient cores of continents, preserve rock for longer spans, but they are not necessarily where civilizations would choose to develop. They're often resource poor, climatically harsh, or geographically isolated. The places best suited for long-term preservation are not the places most conducive to dense, organised societies. This mismatch creates a bias in the record. Even if ruins could survive somewhere, they are least likely to survive where civilizations would most naturally form. Another complication arises from how we define ruins in the first place. We expect geometry, straight lines, right angles, repetition, but erosion actively targets those features. Straight edges concentrate stress, corners fracture, uniform materials weather unevenly. Over time, human-made regularity is systematically dismantled. What remains after millions of years is not a broken building, it is redistributed material. If we did stumble across such material, recognition would depend entirely on context. A block of worked stone removed from its surroundings does not announce itself as a remnant of a city. It looks like stone. Without associated artifacts, stratigraphic coherence, or historical framework, interpretation becomes speculative at best. Geology is cautious for good reason. Natural processes produce astonishing complexity. Hexagonal columns form without design. Crystal lattices mimic intentional patterning. Layered deposits create regular bands. It takes extraordinary evidence to separate intent from accident when dealing with deep time. Ruins, as a category, rarely meet that standard beyond a few tens of thousands of years. There is also an observational bias tied to how we search. We look for what we expect. Our eyes and instruments are trained on certain signatures. If something does not fit those expectations, it is either ignored or explained away. This is not negligence, it is efficiency. But it limits discovery. Looking for ruins assumes that evidence of civilization must be obvious and discrete. Deep time favours diffuse signals. This is why many discussions about ancient civilizations stall at the same point. Someone asks, "Where are the ruins?" The implied answer is that without ruins, the idea fails. That implication rests on a misunderstanding of Earth's memory. Ruins are a short-lived phenomenon. They belong to a narrow slice of time where decay has begun, but erasure is not yet complete. Beyond that slice, the planet does not preserve them as ruins. It processes them as material. Even if we imagine a civilization that built on an unprecedented scale, covering large portions of land with infrastructure, the outcome over millions of years would be the same: fragmentation, mixing, recycling. A large footprint does not guarantee a durable one. There is also a tendency to underestimate how much material Earth moves. Rivers transport billions of tons of sediment each year. Glaciers move entire mountains. Landslides shift landscapes overnight. Over deep time, the cumulative effect is staggering. Surface material is rarely where it started. This movement destroys spatial relationships, which are essential for interpreting ruins. A fallen wall still tells a story if its stones lie nearby. Once those stones are scattered across kilometres, buried, uplifted and eroded again, the story collapses. Another problem lies in the assumption that ruins would be obvious to us even if they existed. We interpret through modern frameworks. An earlier civilization might have used construction methods unfamiliar to us. Materials might have been engineered to behave differently over time. Structural logic might not align with our expectations of load-bearing or permanence. Even within known archaeology, misinterpretation happens regularly. Natural formations are mistaken for human structures and vice versa. That confusion increases as preservation decreases. Deep time maximizes confusion. The idea of ruins also carries emotional weight. Ruins are evocative. They tell stories of loss and continuity. They fit well into narratives. Deep time is indifferent to narrative. It produces outcomes without caring whether they make sense to later observers. If an earlier civilization existed, its remains would not arrange themselves into a legible story waiting to be read. They would be scattered, altered, and incomplete beyond recognition. This does not mean we should abandon the search for evidence. It means we should abandon the expectation that evidence will take familiar forms. Ruins are a comforting idea because they promise clarity. Deep time offers none. A more productive approach is to think in terms of anomalies rather than remnants. Patterns that deviate subtly from what natural processes alone would likely produce. Chemical distributions, isotopic ratios, mineral assemblages that require unusual conditions. These are not ruins. They are footprints in a different medium. Even then, interpretation remains uncertain. Natural systems are capable of surprising complexity. Distinguishing intentional modification from rare natural variation is difficult, especially without corroborating lines of evidence. This uncertainty is not a flaw, it is a boundary. The problem with looking for ruins in deep time is not that we are looking in the wrong place. It is that we are looking for the wrong kind of thing. We are applying a human-scale concept to a planetary-scale process and expecting it to translate cleanly. It does not. Recognizing this shifts the conversation. The question becomes less about whether we have missed obvious ruins and more about how subtle the traces of intelligence might be when filtered through millions of years of geological activity. That shift does not lead to easy answers. It leads to more careful questions. Seen from far enough away in time, Earth stops feeling like a familiar place and starts feeling like a series of experiments. Not versions of the same world with minor adjustments, but fundamentally different environments that happen to share the same planet. When we imagine the distant past, it is easy to picture today's Earth, with a different arrangement of continents or a slightly altered climate. That picture is comforting, but it is also misleading. Ancient Earth was not simply modern Earth with fewer people. It was in many periods a world we would barely recognize at all. This matters deeply for the question we are exploring, because recognition shapes expectation. If the world itself was unfamiliar, then any civilization that arose within it would also be unfamiliar, not just culturally but materially, biologically and environmentally. Expecting such a civilization to leave traces that make sense to us assumes a continuity that did not exist. Start with the air. For much of Earth's history, the atmosphere was radically different from what we breathe today. Oxygen, which feels essential and constant to us, was once a rare and dangerous gas. Early life thrived without it. When oxygen-producing organisms began releasing it in large quantities, it triggered one of the most profound transformations the planet has ever experienced. The Great Oxidation Event altered chemistry, climate and biology on a global scale. For many organisms alive at the time, oxygen was toxic. Entire ecosystems collapsed. Others adapted or emerged in response. Now imagine intelligence arising in a world where oxygen was scarce, or fluctuating, or newly abundant but unstable. Metabolism would differ. Fire might not behave the way it does now, or might not be possible at all. Materials we rely on, such as iron, would react differently in the environment. Corrosion, combustion, and decay would follow unfamiliar rules. That alone reshapes what civilization could look like. Move to the oceans, which have dominated Earth's surface far longer than land has. Ocean chemistry has shifted repeatedly. Salinity, acidity, temperature, and nutrient availability have all varied across deep time. There were periods when oceans were rich with dissolved metals, periods when they were starved of oxygen, periods when vast regions became stagnant and hostile to complex life. Any coastal or marine civilization, if such a thing existed, would be operating in conditions that no longer exist. Structures built in or near those waters would not weather the way modern structures do. Materials would dissolve, precipitate, or transform in unfamiliar ways. Even the concept of a stable shoreline might not apply. Then there is the matter of land itself. Continents have not always looked the way they do now. They have assembled, broken apart, collided, and reassembled multiple times. Mountain ranges rose and vanished. Plains became seas, seas became deserts. The familiar outlines on a modern map are a snapshot, not a constant. Ancient Earth's geography would disorient us completely. There were times when much of the land was barren rock, times when vast swampy forests dominated, times when ice covered regions that are now temperate, times when global temperatures were far higher than anything humans have experienced, times when they were far lower. Civilization, as we understand it, depends heavily on stable climate windows. Agriculture requires predictability. Infrastructure depends on relatively consistent conditions. But Earth's stability is episodic. Long stretches of relative calm are punctuated by upheaval. If intelligence arose during one of those calm windows in the deep past, it would be shaped by conditions that later disappeared. When those conditions changed, the civilization would either adapt, migrate, or fade. None of those outcomes guarantee preservation. Ancient Earth was also noisier in ways that matter. Volcanism was more widespread. Heat flow from the interior was greater. The crust was thinner and more active. Large igneous provinces erupted, covering enormous areas with lava. These events did not just reshape landscapes, they reset them. Imagine a civilization existing in a region later covered by kilometers of volcanic rock. Whatever had been there would be sealed, crushed, heated, and altered beyond recognition. From the surface, there would be no hint of what lay beneath, only a plateau of basalt formed long after the original world had vanished. Biology, too, was unfamiliar. Before complex plants colonized land, there were no forests stabilizing soil. Erosion behaved differently. Sediment moved faster. Rivers braided unpredictably. Landscapes were raw and mobile. Any structures built in such an environment would face relentless instability. Later, when plants did spread across continents, they transformed the planet again. Roots altered weathering rates, soils deepened, carbon cycles shifted, entirely new ecological dynamics emerged. A civilization that developed before or during that transition would inhabit a world in flux. Even gravity's effects were the same, but their consequences were different because the materials involved were different. A world without wood-bearing trees or animals with hard skeletons is not just biologically distinct, it behaves differently at every scale. This unfamiliarity extends to time perception itself. Day length has changed. Earth's rotation has slowed gradually over billions of years. In the distant past, days were shorter. Tides were stronger when the moon was closer. Rhythms that govern biological cycles were not identical to those we experience now. Intelligence, if it arose, would synchronize with those rhythms. Its sense of time, activity, and rest might not map cleanly onto ours. Cultural structures, if they existed, would reflect a different cadence of days and seasons. When we imagine ancient civilizations, we often place them into our world just earlier. We picture familiar skies, familiar coastlines, familiar plants. That mental shortcut makes the idea easier to grasp, but it strips away the most important context. Ancient Earth was not waiting for us. It was busy being something else. This has direct consequences for how evidence might appear, if it appears at all. Materials that are durable today might not have been available or useful then. Materials that were abundant then might be rare or unstable now. Technologies that make sense in one chemical and biological context may be impractical in another. For example, metals that are easily extracted today may have been locked away in forms that were inaccessible without oxygen-rich environments. Conversely, certain compounds might have been easier to work with in ancient conditions, but would not persist in today's atmosphere. This complicates the search for technological signatures. We tend to look for what we know. We scan for metals, alloys, ceramics, and synthetics that fit our understanding of manufacture. An earlier intelligence might have used materials we do not associate with technology at all, or used familiar materials in unfamiliar ways. There is also the question of scale relative to population. Ancient ecosystems often supported lower biomass on land compared to later periods, depending on climate and atmospheric composition. Population densities might have been lower. Settlements might have been smaller and more dispersed. The total material footprint could have been modest, even over long durations. From a geological perspective, modest footprints vanish quickly. Another factor is that ancient Earth lacked some of the stabilizing features we take for granted. Polar ice caps were not always present. Ocean circulation patterns differed. Weather systems followed different rules. Without those stabilizers, environments could change rapidly, even without external triggers. Civilization, if it existed, would be operating in a world where the ground rules shifted more often. Long-term planning would be harder. Continuity would be fragile. The lifespan of any cultural system might be limited by forces far beyond its control. That does not make intelligence less likely. It makes its persistence less visible. there is a tendency to imagine that intelligence, once it arises, inevitably marches forward toward greater complexity and durability. Ancient Earth challenges that idea. Many complex biological systems have arisen and vanished without leaving direct descendants. Complexity does not guarantee continuity. When we acknowledge how unfamiliar ancient Earth truly was, the absence of recognizable evidence becomes less surprising. We are not failing to see something obvious. We are trying to interpret signals from a world that no longer exists using tools calibrated for the present one. This mismatch creates false confidence. We assume that if something significant had happened, it would stand out clearly. But significance is context dependent. What matters within one world may not register in another. Imagine trying to reconstruct human civilization using only chemical traces left after millions of years of tectonic recycling. Without knowledge of our biology, our materials, or our social structures, future observers might note a brief atmospheric anomaly, a redistribution of certain elements, and then a return to baseline. They might debate whether it was biological, geological, or something else entirely. They would not find cities. Ancient Earth compounds this uncertainty by removing familiar reference points. No mammals for much of its history, no birds, no flowering plants, no grasses, landscapes dominated by organisms that no longer exist or exist only in altered forms. Even colours would differ. The sky's composition, the ocean's hue, the dominant vegetation, all unfamiliar. Any civilization arising in such a world would feel alien to us, not because it was exotic, but because it was embedded in a context we no longer share. This recognition does not require us to believe that such civilizations existed. It requires us to admit that our intuitions about detectability are shaped by a world that is not representative of most of Earth's history. Ancient Earth was not simply quieter, it was different in ways that erase familiarity. As we move forward, this realization sharpens the next question. If the world itself was unrecognizable, then what kinds of signals could persist across such radical transformation? What traces are robust enough to survive changes in atmosphere, biology, climate, and crustal dynamics? The search, if it is to be meaningful, must adapt to the world being searched, not the one doing the searching. The planet we know is a recent version. The planet that came before wore many faces. It is tempting to equate intelligence with visibility. We see thinking made tangible through structures, tools, networks, and marks that persist beyond the lives of their creators. From our perspective, intelligence announces itself by rearranging the world in ways that cannot be ignored. Towers rise, roads cut through landscapes, energy flows are redirected. The presence of a thinking species becomes difficult to miss. But this association is not a law of nature. It is a habit shaped by our own moment in time. The idea that intelligence must leave monuments rests on a narrow slice of experience. It assumes that cognition naturally seeks permanence, that understanding inevitably produces objects meant to endure. Yet nothing about intelligence itself demands that outcome. Intelligence is, at its core, a capacity for problem-solving, adaptation, learning, and anticipation. How those capacities are expressed depends entirely on context. Look first at intelligence as it already exists on Earth. Not all intelligent behaviour results in durable artefacts. Many animals demonstrate planning, cooperation, communication, and even tool use without leaving behind anything that would register in the geological record. Problem-solving happens, decisions are made, strategies are adjusted, and then the physical traces vanish almost immediately. Intelligence can be real, effective, and entirely transient. Human intelligence, too, operates this way far more often than we notice. Most of what we think, decide, and coordinate never becomes material at all. Conversations disappear as soon as they end. Knowledge passes from one mind to another without leaving a physical mark. Entire systems of social organisation exist primarily in shared understanding, not in structures. Even today, in a world saturated with material output, the most important aspects of intelligence remain invisible. Monuments are not intelligence. They are one expression of it, shaped by cultural values, available materials and environmental conditions. Remove or alter those conditions, and intelligence will express itself differently. This distinction becomes crucial when we stretch our thinking across deep time. An earlier intelligence, arising under unfamiliar planetary conditions, would not automatically follow the same path we did. Its priorities would be shaped by survival challenges, energy availability, and ecological constraints that may no longer exist. Imagine an environment where large-scale construction is actively disadvantageous. Regions prone to frequent flooding, volcanic resurfacing, or rapid erosion would punish permanence. In such a world, intelligence might favour mobility, adaptability, and minimal physical footprint. Structures would be temporary by design. Materials would be chosen for availability and ease of replacement, not durability. Knowledge would be carried biologically or socially rather than stored externally. From within that civilization, this would not feel like limitation, it would feel like optimization. There is also the question of energy. Monument-building civilizations tend to rely on surplus energy. Quarrying stone, smelting metals, transporting materials, and maintaining large structures all require concentrated resources. Earth's energy distribution has not always favoured such concentration. In many ancient periods, energy may have been abundant but diffuse. Harnessing it efficiently might have required strategies that did not scale physically. An intelligence optimized for low-energy environments might develop sophisticated internal models, communication systems, and social coordination without ever producing large, lasting objects. Its advancement would be measured in stability and resilience rather than expansion. This challenges the assumption that technological progress always leads outward. In reality, many forms of progress lead inward. Refinement, efficiency, and control often reduce physical output rather than increase it. The more precisely a system understands its environment, the less it needs to reshape that environment aggressively. From a planetary perspective, such intelligence would be almost invisible. Another factor is population size. Intelligence does not require large numbers. A species could develop complex cognition and culture while maintaining relatively small populations, especially if its environment places limits on growth. Smaller populations produce fewer artifacts. Fewer artifacts mean fewer chances for anything to survive deep time. Even a long-lived civilization could leave a minimal trace if its material culture remained light. There is also a misconception that intelligence naturally leads to external memory. Writing, recording, and archiving feel inevitable to us because they solved problems we encountered. But they are not universal solutions. Another intelligence might rely on different strategies: genetic encoding, epigenetic inheritance, ritualized behavior, or structured environments could all serve as memory without leaving durable artifacts. Some forms of information storage are exceptionally fragile. Oral traditions can preserve knowledge accurately for thousands of years without leaving physical traces. Behavioral inheritance can transmit complex skills across generations with no material record. These systems work as long as continuity is maintained. When continuity breaks, the information disappears completely. Deep time is very good at breaking continuity. Even within our own history, civilizations have lost vast amounts of knowledge without leaving clear evidence of what was lost. Texts decay, languages die, meanings shift, entire intellectual traditions vanish. Archaeology recovers fragments, not the full scope of the understanding that once existed. Scale that loss up to millions of years, and the idea of a monument-free intelligence becomes less strange. There is also the question of what counts as a monument. We think of monuments as objects meant to last, but intelligence does not need to create objects to create impact. It can shape ecosystems, alter evolutionary trajectories, and influence planetary processes without leaving discrete structures behind. Life itself has already done this. The oxygenation of Earth's atmosphere was not a monument. It was a byproduct of biological activity that transformed the planet irreversibly. That transformation persisted long after the organisms responsible had changed or disappeared. No monument marks their achievement. The evidence is written into the chemistry of the world. An intelligent species could influence its environment in similarly subtle ways. It might manage ecosystems, stabilize climate patterns locally, or alter nutrient cycles to favor long-term balance. These actions could shape the planet without producing anything that resembles a building or tool. Such influence would be difficult to detect after deep time had passed. Chemical and biological signals would blur. Cause and effect would be hard to disentangle. What remained might be interpreted as natural variation rather than intentional design. Another misconception is that intelligence naturally seeks to be remembered. This is a deeply human concern. We build monuments partly to assert continuity, to leave a mark that says, "We were here." That desire is cultural, not biological. It arises from specific psychological and social dynamics. There is no reason to assume that all intelligences share it. An earlier civilization might not care about legacy in the way we do. It might value present stability over future recognition. It might see itself as a transient participant in a long planetary story rather than its climax. From that perspective, leaving no monuments would not be a failure. It would be appropriate. Even if monuments were built, their survival would not be guaranteed. Deep time punishes permanence. Structures meant to last centuries or millennia are trivial to erase over millions of years. Without continuous maintenance, even the most robust constructions collapse into materials that blend seamlessly with their surroundings. We often imagine monuments as durable because we encounter them in a narrow window where they have survived long enough to feel ancient but not long enough to be destroyed. That window is deceptive. It creates the illusion that building in stone is equivalent to building forever. The geological record tells a different story. Stone is temporary. Metal is temporary. All materials are temporary. The planet recycles relentlessly. Another angle worth considering is intelligence that is distributed rather than centralized. Our civilization concentrates intelligence in cities, institutions, and infrastructure. That concentration produces visible traces. A distributed intelligence spread thinly across landscapes or embedded within ecological networks would not create such focal points. In such a system, intelligence might be expressed through coordination patterns rather than physical hubs. Communication might occur through environmental signals. Decision-making could be decentralized. The physical footprint would be diffuse, reducing the likelihood of preservation. Even if such intelligence reached high levels of sophistication, its remains would not cluster into recognizable ruins. They would be scattered, subtle, and easily mistaken for natural features. This possibility becomes more plausible when we consider that intelligence does not have to look like human intelligence. It does not have to organize space the way we do. It does not have to externalize cognition in the same way. It does not have to value accumulation. When we assume that intelligence must leave monuments, we are projecting our own values backward in time. Deep time resists that projection. The absence of monuments does not imply the absence of thought. It implies the absence of preserved structures. This distinction matters because it reframes how we interpret silence. If we expect monuments, silence feels like an answer. If we do not, silence becomes ambiguous. Earth's history is full of ambiguity. Complex processes leave incomplete records. Intelligence, if it arises, would be subject to the same constraints as everything else. Another subtle point is that monuments are often built during periods of excess. They're expressions of surplus energy, labour, and resources. Such periods may be rare and brief even within long-lived civilizations. A society might exist for hundreds of thousands of years and only briefly engage in large-scale construction. If that phase coincided with unfavourable preservation conditions, its traces could vanish entirely. In that case, a civilization could be real, influential and long-lasting, yet appear invisible to us. This is not an argument for believing that intelligence has arisen before without monuments. It is an argument against assuming that monuments are a reliable indicator. The question then shifts. Instead of asking whether we can find evidence of monuments, we ask what kinds of intelligence would naturally avoid producing them, and whether those forms of intelligence are plausible given Earth's history. Given the diversity of life and the variety of environments Earth has hosted, it would be surprising if intelligence had only one possible expression. As we continue forward, this realization complicates the search further. If intelligence can exist without monuments, then the absence of visible ruins loses much of its explanatory power. We are left with a harder task. We must think about indirect signals, subtle patterns, and long-term planetary effects rather than obvious structures. This does not make the question unanswerable. It makes it more careful. Earth does not preserve intention easily. It preserves matter, energy, and change. Intelligence that aligns itself with those flows rather than opposing them would leave fewer scars and fewer clues. If such intelligence ever existed here, its story would not be written in stone. It would be written briefly in behaviour, relationships, and choices that vanished the moment continuity broke. What remains for us, millions of years later, is not proof or disproof, but a reminder. The absence of monuments tells us very little about the presence of minds. It tells us more about how thoroughly the planet erases anything that expects to be remembered. And with that understanding in place, the next question becomes unavoidable. If monuments are unreliable and fossils are biased, then what kinds of signals, if any, could survive long enough to hint at intelligence without relying on physical structures at all? Long after structures collapse and landscapes are rearranged, what tends to linger are not objects but signals, traces of activity that once altered the state of a system. These signals feel promising at first. They seem subtler than ruins, less dependent on intact form. If monuments cannot survive deep time, perhaps signatures can. Perhaps intelligence leaves behind patterns that persist even when physical arrangements do not. But as soon as we begin listing these possibilities, another realization settles in. Most signals are even more fragile than structures. Signals depend on contrast. They exist only as long as something distinguishes them from background conditions. Over millions of years, Earth specializes in removing contrast. Take chemical signals, for example. Changes in atmospheric composition, unusual concentrations of certain elements, or deviations from expected isotopic ratios often come up as potential indicators of past intelligence. We already use these methods to infer biological activity in Earth's deep past and to speculate about life on other planets. In principle, intelligence could produce similar effects. In practice, these signals fade quickly. Atmospheric changes equilibrate, gases mix, reactive compounds break down. Over geological time, the atmosphere resets repeatedly through volcanic outgassing, weathering, biological turnover, and exchange with oceans and rocks. Even dramatic shifts, like oxygenation events, eventually settle into new baselines that erase information about the precise mechanisms that caused them. A civilization might alter atmospheric chemistry for thousands or even tens of thousands of years. Over millions, that alteration would blur into the planet's natural variability. Future observers might detect that something changed, but attributing it to intelligence rather than biology or geology would be extraordinarily difficult. Isotopic signals face a similar problem. Ratios of carbon, nitrogen, or sulfur isotopes can hint at processes that once dominated an environment. But isotopes are constantly redistributed. Weathering transports them. Biological activity reshuffles them. Metamorphism resets them. Over long enough spans, isotope ratios drift toward equilibrium or are overwritten by later events. Even when an unusual isotopic signature survives, it rarely points to a single cause. Multiple natural processes can produce similar patterns. Without context, interpretation becomes ambiguous. Thermal signals fare no better. Waste heat is sometimes suggested as a hallmark of advanced civilization. On human timescales, waste heat accumulates locally. Cities are warmer than their surroundings. Industrial activity leaves thermal fingerprints. But heat dissipates quickly. Earth is efficient at radiating energy into space. Over deep time, localized heating leaves no lasting trace. Even large-scale thermal events like massive volcanic eruptions cool and fade in the record. They leave behind rock, not temperature. A civilization's heat output, unless it triggered runaway planetary change, would vanish almost instantly on geological scales. Electromagnetic signals are even more fleeting. Radio waves, light emissions, electrical activity. All of these define our modern sense of technological presence. None of them fossilize. Once the source stops, the signal is gone, racing outward at the speed of light, never to return. Earth keeps no memory of them. This highlights a fundamental mismatch between how intelligence often expresses itself and how Earth preserves information. Intelligence acts dynamically. Earth remembers statically, and only briefly. Even physical modifications to ecosystems, which might seem more durable, are subject to the same erasure. A civilization could shape landscapes through agriculture, water management, or species selection. Over time, those landscapes would revert, not to their original state, but to something else entirely. Subsequent ecological succession, climate shifts, and evolutionary changes would overwrite earlier patterns. We already see this on short timescales. Abandoned farmland becomes forest. Irrigation channels fill in. Introduced species integrate, evolve, or vanish. After a few thousand years, the original intent is difficult to reconstruct. After a few million, it is effectively gone. Biological signals are often suggested as more robust. Genetic changes, selective breeding, engineered organisms. But genomes evolve continuously. Mutations accumulate. Selection pressures shift. Over long periods, lineages diverge or go extinct. Even deliberate genetic modifications would be diluted, repurposed, or lost entirely, unless they conferred a persistent advantage. And even then, distinguishing intentional modification from natural evolution would be nearly impossible without independent context. Material signals, such as unusual alloys or synthetic compounds, seem more promising at first glance. Some materials are indeed rare in nature. Their presence could raise questions, but rarity is not permanence. Materials break down. They corrode, fragment, dissolve, and react. Over time, they lose the properties that made them distinctive. Even substances that resist decay physically are not immune to chemical alteration. Crystal structures rearrange, elements diffuse, boundaries blur. What was once a manufactured object becomes just another mineral assemblage. There is also the issue of scale. A signal must be widespread enough to survive sampling bias. Earth's crust is vast. We examine only tiny portions of it. A signal confined to a small region, no matter how unusual, is unlikely to be encountered by chance after millions of years. It could exist and still be effectively invisible. Sampling bias alone could erase entire histories from our awareness. Another category often discussed is structural patterning at large scales. Linear features, regular spacing, geometric arrangements that deviate from natural randomness. These can indeed indicate intelligent activity in recent contexts. Over deep time, they dissolve quickly. Tectonics bends and breaks linearity. Erosion randomizes spacing. Burial destroys orientation. After sufficient disturbance, pattern recognition becomes unreliable. Natural processes are capable of producing striking regularity on their own. Separating intentional design from coincidental structure becomes speculative. There is also the problem of overprinting. Earth's history is not a single layer. It is a stack of layers, each one modifying or obscuring the ones below. Later events overwrite earlier signals. A civilization could leave a clear trace, only for it to be partially erased by subsequent processes and then masked entirely by something unrelated millions of years later. This overprinting is relentless. It does not preserve chronological clarity. It blends causes and effects until disentanglement becomes nearly impossible. Another signal sometimes proposed is the alteration of sedimentation rates or erosion patterns. Large-scale land use could, in theory, leave a detectable imprint. But sedimentation is influenced by many factors: climate, tectonics, vegetation, sea level. Untangling the contribution of intelligence from these variables after deep time would be extraordinarily challenging. Even mass extinctions, which leave some of the strongest signatures in the geological record, are difficult to interpret cleanly. We debate their causes for decades, sometimes centuries. If we struggle to assign causes to events that wiped out large portions of life, detecting a subtle, intelligence-driven influence becomes even harder. Time itself compounds the problem. Signals decay not only physically, but interpretively. The further removed we are from an event, the fewer constraints we have on its explanation. Models multiply, certainty shrinks. What begins as a strong hypothesis softens into a range of possibilities. This is why the idea of enduring signals often feels more reassuring than it should. We want to believe that intelligence, if it exists, leaves behind something unmistakable. But unmistakability is rare even in the recent past. Consider how much of human history remains contested despite abundant evidence. Interpretations change as new data emerges. Biases shape conclusions. Now imagine trying to interpret faint signals millions of years removed from their source, stripped of cultural, biological, and environmental context. Signals without stories are hard to read. There is also a deeper issue. Intelligence does not necessarily aim to maximize detectability. Many intelligent systems prioritize efficiency, stability, and survival. These priorities often reduce waste, minimize disruption, and favor integration over transformation. From Earth's perspective, such behavior produces fewer long-lasting signals. A civilization that understood deep time, even intuitively, might actively avoid creating persistent markers. It might design its activities to blend back into natural cycles once they ceased. From its point of view, this could be responsible stewardship. From ours, it would look like absence. This idea challenges a common assumption that advanced intelligence inevitably leaves scars. It suggests the opposite could be true. The more aware a civilization is of planetary processes, the more carefully it might tread. Even if that civilization failed or chose to end, its cleanup could be thorough. Materials reclaimed, structures dismantled, landscapes restored as much as possible. Deep time would finish the job quickly. In that case, the most significant signals might last only thousands of years, not millions. After that, Earth would absorb them completely. There is also the uncomfortable possibility that we have already encountered ambiguous signals and dismissed them. Anomalies in the record that did not fit existing models may have been explained away as rare natural processes. Without a framework that allows for intelligence, interpretation naturally defaults to geology or biology. This is not a conspiracy or a flaw. It is how cautious reasoning works. Extraordinary claims require extraordinary evidence. Signals that cannot meet that standard remain unresolved, but unresolved does not mean non-existent. The recognition that most signals would not survive millions of years does not weaken the question. It clarifies it. It tells us that the absence of clear markers is not surprising. It tells us that if intelligence arose before us, its traces would be subtle, contested, and easy to overlook. It also shifts focus away from the past alone. It encourages us to think about the present differently. What signals are we leaving now that we expect to persist? How many of them actually will? Which of our markers will blur into natural background within a few million years? The answer is likely most of them. Earth is efficient at smoothing disturbances. It is patient. It does not rush. Given enough time, it reduces almost everything to baseline. This understanding raises a difficult but necessary question. If signals are fragile and monuments unreliable, and fossils biased, then where exactly are the blind spots in our assumptions? What parts of Earth's history are most inaccessible to us, and why? Assumptions often feel solid because they sit on top of habits we no longer notice. In geology, those habits are shaped by what we can access, what we can measure, and what has survived long enough to be measured at all. Over time, this creates blind spots, not from negligence, but from practicality. We study what the planet allows us to see. Then, without quite meaning to, we treat that partial view as representative of the whole. This is where many quiet assumptions about Earth's past take root. A geological blind spot is not an empty space. It is a space filled with processes we understand poorly, signals we cannot resolve clearly, or records that no longer exist. These blind spots cluster around certain depths, certain ages, and certain environments. They shape what questions feel reasonable and which ones feel speculative. They also shape why the idea of earlier intelligence feels implausible to many people, even when the underlying evidence is simply incomplete. One of the most significant blind spots lies beneath our feet. We tend to think of Earth's crust as something we can read, like a layered book. In reality, we are reading only the exposed pages, and even those pages have been edited repeatedly. Most of the crust is inaccessible. Drilling projects reach only a few kilometers down, barely scratching the surface relative to continental thickness. Anything buried deeper is effectively invisible unless tectonics brings it back up, altered and fragmented. This means that entire chapters of Earth's surface history are physically unreachable. If a civilization existed on land that was later buried under kilometers of sediment or volcanic rock, we would not know it unless a rare combination of uplift, erosion and exposure occurred. Even then, what emerged would not resemble what went in. Heat, pressure and chemical change would strip away context. Another blind spot lies in time itself. The further back we look, the lower the resolution becomes. Recent geological periods are richly detailed. We can resolve seasonal changes, individual events, even short-lived disturbances. As we move deeper into the past, those details blur. Millions of years compress into single layers. Hundreds of thousands of years merge into indistinguishable averages. Within that compression, brief but significant episodes can vanish entirely. A civilization that existed for a few 100,000 years, long by human standards, could disappear into a layer representing several million years. Its rise and fall would be smoothed into background variation. Unless it caused a dramatic global disruption, it would not stand out. This creates an illusion of continuity. The record looks calm because the turbulence has been averaged away. Environmental bias is another major contributor to blind spots. Certain environments preserve information better than others. Dry, stable regions are favoured. Rapid burial in sediment can help. Cold slows chemical reactions. These conditions are unevenly distributed across the planet and unevenly distributed across time. The environments where civilizations are most likely to develop are often the worst for long-term preservation. Floodplains, deltas, coastlines, volcanic regions. These are dynamic systems. They rearrange themselves frequently. They erase evidence quickly. Meanwhile, the places that preserve rock well are often hostile to sustained human or human-like occupation. Deserts, high plateaus, ancient cratons, sparse resources, harsh climates, low productivity. Preservation bias favours emptiness. This mismatch creates a quiet assumption. If nothing is preserved where civilizations would likely exist, we conclude that nothing existed there at all. Another blind spot emerges from how we classify signals. Geology is excellent at identifying natural processes. That is its strength. When unusual patterns appear, the default assumption is that they result from uncommon but natural causes. This is reasonable. Nature produces extraordinary complexity, but it also means that potential signals of intelligence, if subtle, are likely to be absorbed into existing categories rather than flagged as something new. Anomalies rarely announce themselves as anomalies. Consider how often geological debates hinge on interpretation. A layer of unusual composition might be attributed to volcanic activity, meteor impact, or biological change. Each explanation carries its own assumptions. Intelligence is rarely included in the initial list of possibilities, not because it is impossible, but because it is not part of the standard framework. Frameworks are powerful filters. This filtering effect becomes stronger the further back we look. When evidence is sparse, conservative explanations dominate. Ambiguity is resolved in favour of known processes. Over time, those resolutions solidify into accepted narratives, even when they are provisional. Blind spots also arise from scale mismatch. Human intuition struggles with exponential processes, erosion rates, sedimentation rates, tectonic movement. These processes seem slow until they are given enough time to accumulate. When we underestimate their cumulative effect, we overestimate preservation. We imagine that something large or significant would leave a noticeable mark. We underestimate how efficiently Earth distributes and dilutes material. A mountain range can be reduced to plains. A basin can fill and overflow. Entire coastlines can vanish. Significance does not scale with durability. There is also a blind spot related to repetition. Geological signals that repeat are easier to recognize. Fossils repeat across populations. Volcanic ash layers recur. Sedimentary patterns recur. Civilization does not repeat in the same way. It is a singular configuration in a given place and time. That makes it harder to detect statistically. One-off events are easy to miss, especially when they are subtle. Another assumption hides in how we think about intelligence itself. We often treat intelligence as an on or off state. Either a planet hosts intelligent life, or it does not. This binary thinking overlooks gradations. Intelligence could arise, persist briefly, and disappear without ever reaching the thresholds we associate with civilization today. Such intermediate forms would be especially difficult to detect. They might produce modest environmental changes, localized organization, and transient material culture. Their footprint would sit comfortably within natural variation. Blind spots also appear in how we think about extinction. We tend to imagine extinction as sudden and dramatic. A catastrophic event wipes out a civilization, leaving behind ruins and debris. In reality, many extinctions are gradual. Populations thin. Behaviours fragment. Knowledge transmission fails. The end leaves no sharp boundary. Gradual disappearance leaves no obvious layer. A civilization could fade without a traceable endpoint. Its remnants would be absorbed by ongoing processes rather than sealed beneath a catastrophic marker. From a geological perspective, nothing special happened. Another blind spot lies in our confidence about timelines. Dating methods are powerful, but they have limits. Uncertainties grow with age. Correlating events across regions becomes more difficult. Layers may be missing entirely due to erosion or non-deposition. Gaps in the record are common. Those gaps are not neutral. They represent periods where we have no information. It is easy to forget that absence of data is not data itself. There is also a psychological blind spot worth acknowledging. Humans are uncomfortable with unresolved questions. We prefer answers, even tentative ones, to open-ended uncertainty. Over time, provisional explanations harden into assumptions simply because they are repeated often enough. The idea that we are the first intelligent civilization on Earth fits neatly into a coherent story. It aligns with evolutionary timelines as we currently understand them. It requires fewer caveats. It feels complete. Completeness is appealing, but it can be misleading. Another subtle blind spot comes from disciplinary boundaries. Geology, biology, archaeology, and anthropology each have their own methods and assumptions. Questions that fall between these disciplines can struggle to find traction. An earlier intelligence would sit uncomfortably between geology and archaeology, belonging fully to neither. Geology studies deep time but not intention. Archaeology studies intention but not deep time. The gap between them is a blind spot by default. This does not mean that scientists are unwilling to explore unconventional ideas. It means that tools and frameworks are optimized for certain kinds of questions. Questions that fall outside those optimizations require new approaches, and new approaches take time to develop and validate. There is also the issue of survivorship bias. We study what survived. We infer from survivors. Entire classes of phenomena may have existed and vanished without leaving survivors. Our understanding is built on what made it through the filter, not on what went in. This bias is unavoidable, but it shapes conclusions. When we say that Earth past shows no evidence of earlier civilizations, what we often mean is that Earth's surviving record shows no clear evidence. The distinction matters. Blind spots do not imply hidden truths waiting to be uncovered. They imply limits. Recognizing those limits does not weaken science. It strengthens it by clarifying where certainty ends and inference begins. It allows us to ask better questions, framed around what is knowable rather than what is comforting. As we integrate this awareness, the conversation changes tone. It becomes less about proving or disproving a specific idea, and more about understanding the structure of our ignorance. Where are we blind, and why? This matters not only for the past but for the future. If Earth's record has blind spots large enough to hide entire chapters of history, then our own chapter is not guaranteed to be legible forever. The signals we leave may fade faster than we expect. That realization encourages humility. It also encourages care. The geological blind spots in our assumptions are not obstacles to curiosity. They are guideposts. They tell us where confidence should soften and where imagination should be restrained by process rather than dismissed outright. The blind spots do not tell us what happened. They tell us what we cannot easily see, and in doing so, they quietly reshape the space in which reasonable questions can exist, without demanding answers before the ground is ready to support them. Rather than imagining machines, skylines, or technologies that mirror our own, it is more useful to begin by setting those images aside entirely. Doing so does not make the idea weaker. It makes it more disciplined. If an earlier civilization existed on Earth millions of years ago, it would have emerged within conditions that shaped every aspect of its behavior, priorities, and limits. Those conditions were not ours. Treating that civilization as a variation of modern humanity, simply placed further back in time, would miss the most important factors that defined it. An earlier civilization would first and foremost be a biological outcome of its era. Its intelligence would arise from an evolutionary pathway that no longer exists. That alone would shape everything else. The body that carried that intelligence might not resemble ours closely. Its senses might prioritize different information. Its perception of environment, risk, and opportunity would be tuned to conditions that have since vanished. Intelligence is not abstract. It is embodied, and embodiment matters. That embodiment would influence how such a civilization organized itself. Communication methods might not rely on sound or light the way ours do. They could be chemical, tactile, or behavior-based. Coordination might occur through slow feedback loops rather than rapid exchanges. Decision-making might be distributed rather than centralized. None of these differences require imagining something exotic. They simply follow from the fact that intelligence adapts to context. Context also determines what problems need solving. Human civilization arose in a world where food production, shelter from climate, and competition with other species were central challenges. Agriculture became a foundation because it addressed scarcity under relatively stable conditions. An earlier civilization might have arisen under very different pressures. Food might have been abundant but unevenly distributed. Climate might have been volatile. The most pressing problem might not have been production, but persistence. Under such conditions, expansion would be risky. Concentration would be dangerous. Intelligence might favour dispersion, redundancy, and flexibility. Social structures would emphasise resilience over growth. Cultural continuity might depend on adaptability rather than accumulation. This changes what advancement would mean. Advancement would not be measured by how much the environment was reshaped, but by how well disruption was avoided. Success would be quiet. Stability would be the achievement. From a geological perspective, such a civilization would be difficult to distinguish from the ecosystems it inhabited. Another defining feature would be scale. We tend to imagine civilizations as large because ours is large. Population growth, urbanization, and globalization are central to our experience. But size is not a requirement for intelligence. An earlier civilization might have maintained relatively small populations for very long periods. Population limits could be imposed by resource availability, environmental volatility, or biological constraints. Small populations produce fewer artifacts. Fewer artifacts mean fewer chances for preservation. Over millions of years, even long-lived societies could leave almost nothing detectable. Longevity itself might look different as well. Rather than a single continuous civilization stretching unbroken across time, intelligence might rise and fall in cycles. Knowledge could be gained, lost, and regained. Cultural memory could reset repeatedly. What we think of as a civilization might instead be a pattern of recurring organization that never accumulates into something massive. This cyclical nature aligns more closely with how Earth itself behaves. Stability is temporary, change is constant. Intelligence that survives longest is intelligence that accepts that reality rather than trying to overpower it. Technology, if present, would also reflect those constraints. Tools might be simple, multifunctional, and biodegradable. Materials would be chosen for availability and compatibility with environmental cycles. Long-lasting waste would be avoided not out of foresight, but because it would be maladaptive. Accumulated waste attracts attention from processes that erase. Energy use would be modest, not because intelligence lacked understanding, but because concentrated energy systems are fragile. A civilization that learned to live within diffuse energy flows would trade speed for endurance. Its achievements would be internal rather than external. From our perspective, this might not look like a civilization at all. It is also possible that an earlier civilization was primarily aquatic or amphibious. Earth's oceans have dominated its surface far longer than land has. Marine environments offer stability in some respects and volatility in others. Intelligence arising there would face different pressures. Structures would be transient. Materials would dissolve or corrode. Communication and navigation would follow different rules. Any civilization adapted to such conditions would leave an especially poor record. Oceanic crust is recycled quickly. Sediments are reworked. Signals are diluted. Even biological traces struggle to persist in marine contexts over deep time. If intelligence developed in such an environment, its disappearance from the record would not be surprising. Social organization would also differ. Hierarchies might be shallow or fluid. Leadership might rotate or emerge situationally. Long-term planning might focus on maintaining balance rather than achieving milestones. Without strong incentives for monument building or expansion, the material footprint would remain small. Knowledge transmission would be crucial. Without durable external records, information would live in behavior, ritual, and learning. Teaching would be central, memory would be embodied. When continuity broke, knowledge would vanish quickly. This fragility does not imply primitiveness. It implies dependence on uninterrupted transmission. An earlier civilization might also interact with other species in ways that do not leave clear markers. Coevolution, selective pressures, and ecological engineering could occur subtly. Species distributions might shift. Behaviours might change. Over time, those changes would blend into natural evolutionary narratives. Even if intelligence played a role, disentangling it from other influences would be nearly impossible. Conflict, if it existed, would not necessarily resemble ours. Competition over resources might be diffuse rather than concentrated. Violence might be limited by biological or environmental factors. Large-scale warfare would be unlikely without surplus energy and durable infrastructure. Without war-driven destruction, one of the most obvious archaeological signals would be absent. It is also worth considering that an earlier civilization might have reached a plateau and stayed there. Not every trajectory leads toward rapid change. Some systems find stable configurations and remain there for long periods. Cultural evolution could slow. Innovation could become conservative. Change would be incremental rather than explosive. From a geological standpoint, such stability would be nearly invisible. We often associate civilization with acceleration, faster communication, faster transport, faster production, but acceleration increases fragility. Deep time rewards moderation. Intelligence that survives longest may be intelligence that resists runaway change. This perspective reframes the question entirely. Instead of asking why we do not see evidence of an earlier civilization that looks like ours, we ask whether a civilization that looked nothing like ours would even register as such. The answer is uncertain, but caution suggests probably not. There is also the possibility that an earlier civilization was geographically limited, not global, not planetary. A regional intelligence confined to specific environments could exist for long periods without ever spreading widely. Its footprint would be localized and vulnerable to erasure. If such a civilization existed in a region later submerged, buried, or subducted, its disappearance would be complete. Another uncomfortable possibility is that an earlier civilization might have ended itself deliberately, not through catastrophe, but through choice. If intelligence recognized that its activities destabilized its environment, it might have chosen contraction, simplification, or even extinction as a form of resolution. This idea feels unsettling because it challenges narratives of progress, but it does not require imagining despair or failure. It requires imagining a value system that prioritizes planetary continuity over species persistence. From Earth's perspective, such a decision would leave almost no trace. Speculating about what an earlier civilization might have been like is not an exercise in invention, it is an exercise in constraint. We narrow possibilities by considering what Earth allows to persist, what it erases quickly, and what environments favour subtlety over accumulation. Within those constraints, the image that emerges is not one of grandeur, it is one of quiet intelligence, limited scale, light touch, deep integration with surroundings, vulnerable continuity. That kind of civilization would not leave ruins, it would leave at most hints, and those hints would fade rapidly. This does not make the idea more or less likely. It makes it harder to falsify. It moves the discussion away from dramatic discovery and toward careful reasoning about limits. It also invites reflection on our own trajectory. Many of the features that make our civilization visible also make it fragile. Concentration, accumulation, speed, waste. These traits produce strong signals, but strong signals are often short-lived. If an earlier civilization chose a different path, its success might be measured by how thoroughly it disappeared. The picture that forms is not one of certainty, but of plausibility shaped by restraint. An earlier civilization, if it existed, would not announce itself to us across millions of years. It would exist briefly within its own moment, shaped by a world that no longer exists, and then dissolve into the same processes that have erased so much else. What remains for us is not evidence, but a framework for thinking carefully about what absence really means when time itself has had so much opportunity to smooth everything away. Resisting the urge to make earlier intelligence extraordinary is one of the hardest parts of thinking clearly about this subject. The moment we imagine a civilization before ours, the imagination tends to leap immediately to extremes. Starships, lost super technologies, mythic beings whose achievements dwarf our own. Those images are compelling, but they are also shortcuts. They replace careful reasoning with spectacle, and in doing so they quietly distort the question we are actually trying to examine. If an earlier civilization existed on Earth, it would not need to be spacefaring to be advanced, and it would not need to be mythic to be significant. It would simply need to be different in ways shaped by its time, its planet, and its constraints. The assumption that advancement inevitably leads to space travel is a very recent one. It arises from our own historical moment, where rapid technological acceleration coincided with the discovery that space was accessible. Even now, spacefaring capability is fragile, resource-intensive, and dependent on a narrow set of conditions. Remove those conditions and the trajectory disappears. There is nothing in intelligence itself that demands expansion beyond a planet's surface. An earlier civilization might never have looked outward at all. Its challenges would be planetary, not cosmic. Climate stability, resource cycling, ecological balance, survival across environmental shifts. These are difficult problems that require deep understanding, long planning horizons, and collective coordination. Solving them well does not require leaving the atmosphere. In many cases, leaving would introduce more risk than reward. From that perspective, a civilization that remained bound to its planet would not be limited. It would be focused. Likewise, the idea that earlier intelligence must have been mythic often arises from frustration with absence. When evidence is lacking, imagination fills the gap with grandeur. But grandeur is not a logical necessity. It is a narrative impulse. Deep time does not favour mythic scale. It favours moderation, repetition, and survival within constraints. A civilization that fit comfortably within Earth systems would not feel legendary to itself. It would feel ordinary, practical, and continuous. Ordinary does not mean simple. Complexity can exist without spectacle. Consider how much coordination is required for ecosystems to function. Nutrient cycles, population dynamics, feedback loops, resilience to disturbance. These systems are not directed by a central authority, yet they display remarkable stability over long periods. Intelligence embedded within such systems could operate with comparable subtlety. Such intelligence would not announce itself through massive construction projects. It would express itself through timing, restraint, and adaptation. It would make choices that minimize disruption because disruption invites erasure. This is where the word different becomes more useful than advanced. Different priorities produce different outcomes. Different environments reward different strategies. A civilization arising under ancient Earth conditions would not share our assumptions about growth, speed, or permanence. It might not value accumulation. It might not equate success with expansion. It might not view progress as linear. Its sense of identity might be ecological rather than territorial. Belonging might be defined by relationships rather than borders. Continuity might matter more than innovation. From our perspective, this could look stagnant. From within that civilization, it could look stable. There is also the matter of scale in time rather than space. Our civilization measures success in years, decades, centuries. An earlier intelligence might operate on much longer cycles. Planning horizons could extend across thousands of years. Change would be slow by design. Rapid transformation would be seen as dangerous. Such temporal patience would reduce the need for dramatic interventions. It would also reduce the production of sharp signals that geology could later detect. Another common misconception is that intelligence naturally produces technology that escapes biology. Machines, artificial systems, non-organic structures. This is again a projection from our own experience. An earlier civilization might never have made that leap, not because it lacked capability, but because it lacked incentive. Biological systems are extraordinarily capable, They self-repair. They self-replicate. They adapt. An intelligence deeply integrated with biological processes might enhance them rather than replace them. Its tools could be living systems. Its infrastructure could be ecological relationships. Its technologies could dissolve when no longer needed. Such choices would leave little behind. This does not require imagining a utopia or a flawless society. Conflict, error, and limitation would still exist, but the resolution of those conflicts would not necessarily take material form. Social negotiation, behavioral norms, and adaptive strategies leave no fossils. There is also a strong tendency to imagine earlier intelligence as singular and unified, as though a civilization must be a coherent global entity. In reality, intelligence could arise in pockets, localized cultures, regionally adapted systems. These might never merge into a planet-spanning network. A distributed intelligence of this kind could exist for long periods without ever producing a unified material footprint. Its disappearance would be fragmented rather than catastrophic. From a geological standpoint, nothing remarkable would mark its end. The absence of mythology in this picture is intentional. Mythology often reflects how later cultures try to make sense of gaps in understanding. It projects meaning backward. An earlier civilization, if it existed, would not be mythic to itself. It would be engaged in daily concerns: weather, food, relationships, survival, continuity. Its disappearance would not be framed as a legend. It would simply happen. This perspective also removes the expectation of technological superiority. Earlier does not mean more advanced. Evolution does not guarantee improvement in every direction. Intelligence could arise, adapt well to its environment, and never develop capabilities that we would consider impressive. From our standpoint, such intelligence might even appear primitive if we could observe it directly. But that judgment would reflect our values, not its effectiveness. Effectiveness is context-dependent. A civilization optimized for ancient Earth conditions would be poorly suited to modern Earth, and vice versa. Technologies, social systems, and knowledge frameworks are not transferable across radically different environments. This makes comparison misleading. It also makes detection harder. We look for what we know how to recognize. Difference looks like absence. There is another reason the just different framing matters. It avoids the trap of inevitability. If earlier intelligence must be either inferior to us or vastly superior, then its absence becomes meaningful in ways that distort reasoning. Either it failed because it was weak, or it vanished because it transcended Earth entirely. Both options are comforting. They preserve our sense of narrative importance. A civilization that was simply different challenges that comfort. It suggests that intelligence does not follow a single arc. It branches, it adapts, it sometimes persists quietly and then disappears without climax. That idea is harder to fit into a story with heroes and endings. It is also more consistent with how Earth actually behaves. Earth does not produce epics, it produces processes. Another misconception tied to mythic thinking is that earlier intelligence would have needed to leave warnings, artifacts, or messages for future beings. This assumes a concern for unknown descendants separated by millions of years. That concern is rare even within our own civilization, which struggles to preserve information for a few centuries. An earlier intelligence might not anticipate another intelligent species arising after it. It might not see itself as a predecessor. It might see itself as one participant in a long, ongoing planetary story with no guaranteed audience. In that context, leaving messages would feel pointless. Even if messages were left, their survival would be unlikely. Languages decay. Symbols lose meaning. Materials degrade. Context disappears. A message without context is noise. The absence of mythic artifacts does not imply the absence of meaning. It implies that meaning was lived, not archived. This also reframes how we think about disappearance. A civilization does not need to be destroyed dramatically to vanish. gradual decline, fragmentation, or absorption into other systems is enough. Knowledge can be lost without violence. Organisation can dissolve without catastrophe. Deep time prefers these quiet endings. There is also the possibility that an earlier civilization never thought of itself as a civilization. The category itself is a human construct. It reflects how we group certain patterns of behaviour and organisation. Another intelligence might not draw the same distinctions. It might not separate itself conceptually from its environment. From our perspective, we might struggle to identify something as a civilization if it does not self-identify that way. This matters because classification depends on shared definitions. Without those, recognition fails. The more carefully we remove assumptions about scale, ambition, technology, and narrative, the more plausible a low-visibility intelligence becomes. Not inevitable, not proven, but plausible within the constraints Earth imposes. Such an intelligence would not be spacefaring. It would not build monuments meant to outlast geology. It would not carve its story into stone. It would solve problems locally, adaptively, and temporarily. And then it would be gone. This picture is unsatisfying if one is searching for revelation. It offers no dramatic discovery, no lost golden age, no hidden lineage to claim. What it offers instead is coherence, a model that aligns with what we know about deep time, erosion, preservation bias, and planetary behaviour. It also offers a mirror. When we look at this hypothetical civilization and strip away the mythic elements, what remains is not alien. It is simply intelligence operating under different constraints. The differences are not matters of capacity but of context. That realization invites an uncomfortable question about us. How much of what we consider essential to civilization is actually contingent? How much of our visibility is the result of a brief alignment of resources, climate, and opportunity? How much of our legacy depends on conditions that will not last? If an earlier civilization existed and left almost nothing behind, it does not mean it failed. It may mean it succeeded on terms that deep time does not reward with memory. Long after intentions fade and systems dissolve, the planet continues without pause, responding only to forces that operate regardless of who or what happens to be present on its surface. Earth does not wait for civilizations to finish their stories. It does not slow its cycles to preserve meaning. It simply moves on, guided by physics, chemistry, and energy flows that are indifferent to memory. This indifference is not hostility, it is function. From the planet's perspective, a civilization is a transient configuration of matter and energy, no different in principle from a forest, a reef, or a river system. All of these arise, persist for a time, interact with their surroundings, and eventually change or disappear. Earth is not built to privilege one over the others. It responds to scale, duration, and impact, not to intention or intelligence. This is why the idea of the planet moving on is so central to understanding why earlier civilizations, if they existed, would leave so little behind. Earth operates on cycles that vastly exceed the lifespan of any organized system that depends on stability. Plate tectonics rearrange continents. Climate oscillates between extremes. Sea levels rise and fall. Atmospheric composition shifts. These processes do not reset after a civilization ends. They continue uninterrupted, erasing context as they go. When a civilization disappears, whether gradually or abruptly, the planet does not mark the occasion. There is no boundary layer that says something important has ended. There is only continuity. This continuity is what makes erasure so effective. Consider what happens immediately after a civilization ceases to maintain itself. Infrastructure begins to fail. Water infiltrates systems designed to exclude it. Vegetation colonizes open spaces. Animals return. Microorganisms accelerate decay. These changes are not slow. Within decades, structures soften. Within centuries, they collapse. Within millennia, they fragment into materials that no longer carry clear purpose. At that point, Earth's larger processes take over. Erosion redistributes fragments, sediment buries remnants, chemical reactions alter composition, tectonic movement shifts positions. Over longer spans, burial leads to heating and pressure that erase remaining structure. Eventually, the material is recycled completely. At no stage does Earth pause to preserve information about what came before. This is not unique to civilizations. Entire ecosystems vanish the same way. Coral reefs die, are buried, and become limestone. Forests turned into coal or disappear without trace. Species go extinct, leaving behind nothing but gaps inferred from what came later. Earth absorbs all of it into ongoing cycles. Civilizations are not exempt. One reason this feels counterintuitive is that we experience the planet on a short time scale. We see landscapes as stable backdrops. Mountains feel permanent, coastlines feel fixed. But these impressions are illusions created by brief observation windows. Over millions of years, even the most imposing features are temporary. The Himalayas are young, they are already eroding. Given enough time, they will flatten, their material carried away to form new rock elsewhere. The same fate awaits every structure, natural or artificial. Earth does not preserve peaks, it redistributes them. This redistribution has an important consequence. Material from a civilization does not simply disappear, it becomes part of something else. Buildings become sediment, tools become minerals, waste becomes background chemistry. The distinction between intentional and unintentional matter dissolves. From a geological standpoint, this is efficient. The planet avoids accumulation. It prevents clutter. It maintains dynamic equilibrium. From a historical standpoint, it is devastating. History relies on context. It requires spatial relationships, sequences, and associations. Earth's processes are exceptionally good at destroying context while conserving mass. They preserve atoms while erasing stories. This is why even dramatic endings would not guarantee remembrance. A civilization could end in fire, flood, or impact. Those events might leave a detectable layer. But that layer would record the event, not the civilization. Future observers might see evidence of disruption without any indication of who caused it or why. Even mass extinctions, which leave some of the clearest geological signatures, are difficult to interpret. Their causes are debated long after the fact. Their effects are easier to see than their origins. A civilization that triggered its own end would not leave behind a neat explanation. Earth's tendency to move on also applies to chemical and biological legacies. Changes introduced by intelligence might persist briefly, but they would not remain fixed. Ecosystems adapt. Species evolve. Chemical gradients diffuse. Feedback loops stabilize new conditions. What looks like a permanent change from one moment becomes a transitional phase from another. This is especially true for biological interventions. Introducing or modifying species could alter ecosystems for thousands or tens of thousands of years. Over millions, those changes would be absorbed into evolutionary trajectories. Distinguishing intentional manipulation from natural selection would become nearly impossible. Even if intelligence played a decisive role, the planet would rewrite the outcome as biology. There is also a limit to how much information Earth can carry forward. The geological record is not infinite. It is constantly pruned by erosion, subduction, and metamorphism. Old layers are destroyed to make room for new ones. Memory is not cumulative. It is selective and temporary. This means that Earth cannot remember everything, even if it wanted to. Its storage capacity is constrained by its own activity. Civilizations, which are highly localized and short-lived relative to geological time, are especially vulnerable to this limitation. Another aspect of Earth's indifference is that it does not privilege complexity. Simple systems and complex systems are treated the same way. Both are subject to the same physical laws. Both are broken down when conditions change. We often assume that complexity deserves preservation, that intelligence should be remembered. Earth does not share that assumption. This does not mean that intelligence has no impact. It means that impact is evaluated only in terms of energy flow and material redistribution. If intelligence alters those flows significantly and persistently, traces may remain. If not, the planet moves on without registering the difference. From this perspective, the most enduring influences on Earth's history are not minds, but processes that operate at planetary scale. Plate tectonics, atmospheric chemistry, solar input, orbital dynamics. Life itself, in aggregate, has reshaped the planet more than any individual species. An earlier civilization, unless it altered Earth on that scale, would be a footnote at best. This can feel discouraging, but it is also clarifying. It explains why the absence of evidence is not surprising. Earth is not designed to be an archive of intelligence. It is designed to be habitable through constant change. Habitability requires forgetting. If Earth preserved everything, it would choke on its own past. Sediment would pile endlessly. Chemistry would stagnate. Landscapes would freeze. The same processes that erase also enable renewal. Forgetting is not a flaw, it is a requirement. This means that even if Earth once hosted an advanced civilization, the planet would not behave differently afterward. There would be no scar that says, something important happened here. There would be no obligation to remember. The planet would simply continue adjusting to new conditions. There is also an emotional dimension to this realization. Humans attach meaning to continuity. We value legacy. We build records because we want to be remembered. Earth does not share that emotional framework. It operates without regard for meaning. This difference in perspective creates a mismatch between what we expect and what the planet provides. We expect memory. Earth provides cycles. That mismatch often leads to frustration. We look for traces and find silence. We interpret silence as absence. In reality, silence is the expected outcome of a system that prioritizes balance over record keeping. Another reason the planet moves on so effectively is that it is not static, even in the absence of life. Geological processes predate biology and will outlast it. Continents moved before life colonized land. Oceans formed and evaporated before complex organisms existed. Earth has always been dynamic. Civilizations arise within that dynamism. They do not pause it. Even if intelligence learned to anticipate planetary changes, it could not stop them indefinitely. At best, it could adapt. Eventually, adaptation would fail as conditions drift beyond tolerable ranges. When that happens, Earth does not mourn. It adjusts. This is why asking why the planet would move on is almost the wrong question. It cannot do otherwise. Movement is how it functions. Stability is temporary. Change is constant. The idea that Earth would preserve a civilization's legacy implies a kind of agency the planet does not possess. It does not decide what to keep. It responds to forces. Understanding this helps remove a layer of disappointment from the question. We stop expecting Earth to validate our importance. We stop treating the absence of evidence as a verdict. Instead, we see it as a consequence of scale mismatch. Civilizations operate on timescales that are negligible to planets. Even 1 million years is brief in geological terms. Earth has had thousands of such intervals to erase and repurpose whatever arose on its surface. This also reframes our relationship to the planet now. The idea that Earth will move on regardless of what we do can feel unsettling, but it is also grounding. It reminds us that permanence is not an option. Influence is temporary. Responsibility exists within limits. If an earlier civilization existed and vanished without a trace, it does not mean it was insignificant. It means it was finite. Like everything else that has ever lived here, the planet's ability to move on does not negate the experiences that occurred. It simply ensures that those experiences do not persist beyond their moment. This perspective also guards against romanticizing the past. There is no lost golden age waiting to be uncovered. There is no promise that intelligence leaves a cumulative legacy. There is only participation in a system that continues long after participants are gone. As this understanding settles, the conversation becomes quieter. The question is no longer whether Earth remembers earlier civilizations. It is whether memory is something we should expect from a planet at all. Earth remembers change, not intent. It records shifts in energy, chemistry, and structure. It does not record purpose. That distinction explains almost everything about the silence we encounter when we look deep into the past. The planet has moved on from countless configurations of life, climate, and geography. It will move on from us as well. That is not a failure of intelligence. It is the condition under which intelligence arises at all. Uncertainty can feel like an irritation at first, something to be resolved or pushed aside so that a cleaner story can take its place. We are taught, often without realizing it, that not knowing is a temporary failure rather than a stable condition. Questions are supposed to move toward answers. Gaps are meant to be filled. Ambiguity is framed as a problem waiting for a solution. Yet when it comes to deep time, to planets, to histories measured in hundreds of millions of years, not knowing is not an obstacle. It is the most honest position available. There is a particular kind of humility that emerges when we accept this, and it is not a humiliating kind. It is not about diminishing ourselves or our capacity to understand. It is a comforting humility, one that eases the pressure to force certainty where the ground simply does not support it. When we ask whether Earth once hosted an advanced civilization millions of years ago, we're asking a question that stretches beyond the limits of our tools, our records, and even our intuitions. The temptation is to resolve that stretch by leaning hard in one direction or another. Either it must have happened, hidden cleverly beyond detection, or it must not have happened at all because surely we would know. Both positions offer relief. They close the question. They let the mind rest. But deep time rarely offers that kind of rest. The geological record is incomplete by nature. It is fragmented, biased, and constantly revised. Even for events we are confident occurred, our understanding remains provisional. New data reshapes timelines. Better models revise interpretations. What once felt settled becomes uncertain again, not because knowledge has regressed, but because it has matured. In this context, admitting uncertainty is not weakness. It is alignment with reality. There is comfort in recognizing that some questions do not yield clean answers, not because they are unimportant, but because they are too large to be captured fully. Earth's history is one of those questions. It is vast enough that any attempt to summarize it into a single, coherent narrative will inevitably leave something out. The idea that we might never know whether an earlier civilization existed can feel unsatisfying. It runs against a cultural instinct to uncover, to reveal, to bring hidden truths into the light. But there is another way to experience that uncertainty, one that does not feel like failure. Not knowing creates space. It allows us to explore possibilities without committing to conclusions. It encourages careful reasoning instead of premature certainty. It invites humility without demanding resignation. In the case of deep time, it also keeps us honest about what evidence can and cannot tell us. There is a tendency, especially when discussing speculative ideas, to frame uncertainty as a gap that must be closed before meaningful discussion can begin. In reality, uncertainty is often the foundation of meaningful discussion. It defines the boundaries within which reasoning remains responsible. When we acknowledge that Earth's record cannot definitively confirm or deny the existence of an earlier civilization, we are not admitting ignorance in a dismissive sense. We are recognizing the limits imposed by physics, chemistry, and time itself. Those limits are not arbitrary. They arise from processes we understand well. Erosion erases context. Subduction destroys surfaces. Metamorphism resets material. Chemical signals diffuse. biological traces evolve. Each of these processes has been studied in detail. Together they explain why certainty fades as we look further back. Understanding those processes makes uncertainty feel earned rather than unsettling. There is also a psychological shift that happens when we stop demanding answers that the evidence cannot provide. Curiosity becomes less anxious. It stops racing toward resolution and starts moving more deliberately. Questions become places to linger rather than hurdles to clear. This is especially valuable when thinking about our place in Earth's history. The assumption that we must know whether we are first often carries an unspoken emotional weight. Being first feels special. Being unique feels validating. It reinforces narratives of purpose and destiny. Letting go of certainty around that assumption can feel threatening, as though it undermines our significance. But significance does not require exclusivity. We do not need to be the first to matter. We do not need to be alone in history to be meaningful. The comfort of humility comes from recognizing that our value does not depend on occupying a privileged position in deep time. In fact, humility often enhances meaning rather than diminishing it. When we accept that Earth's history is larger than our understanding, we begin to see our moment differently. Our civilization becomes one episode among many, not the culmination of a long march, but a participant in an ongoing process. That framing reduces pressure. It replaces entitlement with responsibility. Another comforting aspect of not knowing is that it protects us from overconfidence. Overconfidence narrows thinking. It leads us to dismiss possibilities prematurely. It encourages us to treat current models as final rather than provisional. Deep time resists that attitude. Geology is a discipline built on revision. New techniques uncover new layers. Better dating refines timelines. Long-held assumptions are overturned regularly. Accepting uncertainty keeps us open to those revisions without destabilizing our sense of understanding. This openness matters because the idea of earlier civilization sits at the edge of multiple disciplines. It intersects geology, biology, archaeology, and philosophy. No single field can resolve it alone. Each brings partial insight. None can claim completeness. Humility allows those partial insights to coexist without forcing them into a single answer. There's also an ethical dimension to this humility. When we acknowledge how easily Earth forgets, we're reminded that our own actions are not guaranteed to leave a lasting record. The planet will not preserve our intentions, only our impacts. This awareness can encourage care rather than complacency. Knowing that we may not be remembered does not make our choices meaningless. It makes them immediate. The comfort here comes from releasing the need for permanence. We do not need to carve our story into the planet to justify our existence. Meaning can exist within moments, relationships, and experiences that leave no trace beyond themselves. This is a difficult idea in cultures that equate success with legacy, but it is a freeing one. There's also comfort in recognizing that not knowing keeps wonder alive. Certainty closes doors, uncertainty leaves them open. The question of whether Earth once hosted an earlier civilization invites imagination, but not the kind that runs wild. It invites disciplined imagination, guided by what we know about planetary processes. This balance between imagination and restraint is rare and valuable. It allows us to explore ideas without turning them into beliefs. It encourages curiosity without demanding allegiance. In that space, the idea of an earlier civilization becomes less about proving something extraordinary and more about understanding Earth more deeply. It becomes a lens through which we examine erosion, preservation bias, scale, and the limits of detection. Even if the answer were definitively no, that exploration would still be worthwhile. Not knowing also guards against the urge to project ourselves backward. When we accept uncertainty, we are less tempted to imagine the past as a mirror of the present. We become more cautious about imposing modern values, technologies, and narratives onto worlds that operated under different conditions. This caution leads to better questions. Instead of asking why we have not found evidence, we ask what kinds of evidence could realistically survive. Instead of assuming absence implies impossibility, we ask how likely detection actually is. Instead of framing the past as a puzzle waiting to be solved, we frame it as a system shaped by constraints. Those shifts in framing are subtle, but they matter. There is also a personal comfort in acknowledging that some things will remain unresolved. In everyday life, uncertainty often feels stressful because it demands action. In deep time, uncertainty asks nothing of us. It simply exists. We are free to sit with it without needing to respond. This can be calming. It allows the mind to slow down, to move away from problem-solving mode and into reflective mode. Questions become companions rather than challenges. The unknown becomes spacious rather than threatening. This is particularly fitting for a topic like this one, which sits at the intersection of science and philosophy. Science tells us what we can test and infer. Philosophy helps us live with what remains beyond reach. Both are needed here. The humility of not knowing also encourages respect for complexity. Earth's systems are not simple. They interact across scales and feedback loops that resist reduction. Intelligence, if it arises, becomes part of that complexity rather than standing outside it. Recognizing this makes simplistic narratives feel inadequate. It also tempers the desire for sensational conclusions. The idea of lost civilizations can easily drift into fantasy if not grounded in restraint. Humility keeps speculation tethered to process rather than spectacle. Another aspect of this comfort lies in continuity. Even if we cannot know what happened millions of years ago, we can know how Earth behaves now. Those behaviours provide insight into what is likely and what is not. They give us a framework for thinking responsibly about the past without claiming certainty. Within that framework, uncertainty is not a void. It is a structured space defined by known limits. Accepting those limits also has implications for how we approach future discoveries. If evidence emerges that challenges current assumptions, humility makes room for it. It prevents defensiveness. It allows revision without crisis. Science advances not by clinging to certainty, but by revising it. The question of earlier civilizations does not demand belief or disbelief. It invites patience, patience with incomplete records, patience with ambiguous signals, patience with the idea that some aspects of Earth's history may never be fully accessible. This patience is itself a form of respect, both for the planet and for the process of inquiry. There is a final layer of comfort in realizing that not knowing does not diminish wonder. If anything, it preserves it. Certainty often flattens experience. Mystery deepens it. The idea that Earth's past contains chapters we may never read adds richness rather than emptiness. It reminds us that we are participants in a story far larger than ourselves, one that did not begin with us and will not end with us. That realization can feel small, but it can also feel grounding. We are not required to carry the weight of being unique in all of history. We are allowed to exist without being exceptional in a cosmic sense. That is a gentle relief. As we hold this humility, the conversation naturally turns inward. The question shifts from what we can prove about the past to what this perspective reveals about us. How do we live, knowing that Earth forgets? How do we value our moment, knowing it is temporary? How do we act, knowing that certainty is limited? These questions do not seek answers carved in stone. They invite reflection. The comfort of not knowing lies in allowing those reflections to unfold without pressure. We do not need to solve Earth's deepest mysteries to live thoughtfully within them. We do not need to claim a definitive place in history to act with care. The silence of deep time does not demand interpretation. It allows contemplation. Looking closely at this idea for long enough, it becomes clear that it is not really about the distant past at all. The question of whether Earth once hosted an advanced civilization millions of years ago functions less like a historical inquiry and more like a mirror. What it reflects back is not ancient cities or vanished intelligences, but our own assumptions, anxieties and values, quietly arranged in a way that is easier to notice. Thought experiments have a peculiar strength. They loosen certainty without demanding replacement. They allow us to explore boundaries without crossing them. In this case, the boundary is not geological evidence, but self-perception. What this line of thinking reveals most clearly is how deeply we want our presence to mean something in absolute terms. When people encounter the idea of an earlier civilization, reactions tend to cluster around a few familiar emotions. Skepticism, often sharp and immediate. Curiosity, sometimes mixed with unease. Occasionally excitement at the possibility of a hidden lineage. Beneath those reactions lies something more consistent. A concern about status. Were we first? Are we unique? Do we represent a turning point or just another moment? These questions are not scientific in origin. They are existential. We care about being first because first implies primacy. It suggests that intelligence was waiting, building toward us, that our arrival completed something unfinished. That story places us at the centre without needing to say so explicitly. It is comforting because it gives our moment a kind of inevitability. The possibility that we were not first disrupts that comfort. Not because it threatens our abilities or achievements, but because it reframes them. If intelligence could arise before and disappear without ceremony, then intelligence is not destiny. It is not a guaranteed upward arc. It is contingent, fragile, and temporary. That realization can feel unsettling, but it also strips away unnecessary weight. Much of how we talk about civilization is saturated with permanence. We speak of legacy, impact, and progress as though they are cumulative and enduring by default. We design systems to last. We argue about what future generations will inherit. These concerns are practical and often necessary, but they can also blur into a belief that endurance is the ultimate measure of worth. The thought experiment challenges that belief quietly. If an earlier civilization lived meaningful lives, solved problems, formed relationships, and then vanished without trace, was it diminished by that disappearance? Did its lack of permanence negate its value? Most people would say no when asked directly. Yet when applied to ourselves, the idea feels more uncomfortable. This discomfort reveals how closely we tie meaning to remembrance. We want to be known. We want our existence to register beyond our own experience. We want some part of us to persist. The planet's indifference to memory forces us to confront the possibility that persistence is not guaranteed, and perhaps not even likely. There is also a subtler revelation embedded here. We tend to think of intelligence as something that culminates in control. Mastery over environment, mastery over matter, mastery over fate. The idea of a civilization that did not pursue those outcomes, or that pursued them only modestly, feels incomplete to us. But that reaction says more about our values than about intelligence itself. We live in a moment where expansion has been rewarded. Growth, speed, and accumulation have been adaptive strategies under specific conditions. Those strategies have shaped how we define success. When we imagine earlier intelligence, we instinctively project those definitions backward. The thought experiment exposes that projection. It asks whether intelligence must always express itself in ways that are loud, visible, and disruptive. It asks whether restraint, balance, and subtlety might also be valid expressions of advanced cognition. The discomfort many people feel with that idea reveals how deeply we associate intelligence with domination rather than coexistence. There is also a revealing tension between curiosity and control. We want to know whether earlier civilizations existed, but we also want to know in a way that reinforces our confidence. Clear evidence, clear conclusions. The idea that the question may remain open indefinitely is frustrating, not because curiosity demands closure, but because control does. Control prefers certainty. This is why the humility discussed earlier is so important. It is not about lowering expectations. It is about adjusting them to match reality. Earth's history does not owe us clarity. Our desire for answers does not shape what the planet preserves. Accepting that reveals something important about how we approach knowledge more broadly. We are most comfortable when questions fit within systems we already understand. When they do not, we tend to force them into those systems or dismiss them entirely. The idea of earlier civilizations resists both impulses. It cannot be easily proven, and it cannot be easily disproven. It sits in a space that demands patience and restraint. Our response to that demand is revealing. Do we become defensive? Do we dismiss the question outright? Do we inflate it into fantasy? Each reaction says something about how we handle uncertainty. There is also an ethical reflection embedded here. If Earth forgets so thoroughly, then our current civilization's impact will not be preserved as intention, only as consequence. Future observers, if they exist, will not read our debates or understand our motivations. They will see altered systems, changed chemistry, redistributed matter. That realization can feel sobering. It strips away the illusion that history will judge us kindly or harshly based on narrative. The planet does not judge, it responds. What remains will be what we changed, not what we meant to change. This reframing shifts responsibility away from legacy and toward immediacy. If meaning is not guaranteed by endurance, then meaning must be located elsewhere. In how we treat each other, in how we respond to constraints, in how we act within our brief window. The thought experiment does not tell us whether we are special. It asks why we need to be. Another revelation lies in how quickly discussions of earlier civilizations drift into extremes. Either the idea is ridiculed as pseudoscience, or it is embraced as evidence of lost golden ages. Both responses bypass the harder work of careful reasoning. That bypass is instructive. It shows how uncomfortable we are with middle ground, with ideas that do not resolve cleanly, with possibilities that remain conditional. Our culture often rewards decisive stances, even when the evidence does not support them. Deep time does not reward decisiveness, it rewards caution. Engaging with this idea thoughtfully requires slowing down, tolerating ambiguity, and resisting the urge to anchor conclusions prematurely. That skill is not limited to geology or planetary science. It applies to many areas of life. The discomfort we feel here is practice for living with uncertainty elsewhere. There is also something revealing about how strongly we associate intelligence with technological escalation. The idea that an earlier civilization might not have pursued space travel, massive construction, or global domination feels almost disappointing to some people. It lacks spectacle. But spectacle is not intelligence, it is performance. This realization invites reflection on our own trajectory. Are we equating advancement with visibility because visibility has been adaptive for us, or because it is inherently superior? Are there forms of intelligence we undervalue because they do not produce dramatic outputs? The thought experiment opens that question without answering it. It also highlights how much of our self-understanding depends on contrast. We define ourselves by what came before. If nothing comparable existed, we feel more distinct. If something did, our distinctness feels threatened. But distinctness is not the same as worth. We do not need to be unprecedented to be meaningful. We do not need to be the first to matter. This is a simple statement, but it runs counter to many cultural narratives. The idea of earlier civilizations gently erodes the myth of exceptionalism without replacing it with cynicism. It does not say that we are insignificant. It says that significance does not require uniqueness. That is a quiet but profound shift. Another revealing aspect is how easily we assume that intelligence must leave a cumulative legacy. That assumption mirrors how we structure our own lives. Careers, accomplishments, records. We measure success by accumulation over time. Deep time undermines that metric. If accumulation is temporary, then success may need to be redefined. The thought experiment nudges us toward that redefinition without prescribing it. It asks whether a life or a civilization can be successful, even if it leaves no lasting trace. Most people would say yes, in personal terms. We accept that individual lives are meaningful even though they end. Extending that acceptance to civilizations is more difficult, but the logic is the same. The resistance we feel reveals how much we want our collective efforts to transcend mortality. There is also a quieter revelation here, one that emerges only after sitting with the idea for a while. The question of earlier civilizations often begins as curiosity about the past, but it gradually becomes a question about restraint, about limits, about what happens when systems do not grow endlessly. Earth imposes limits relentlessly. Climate, resources, space, time. Intelligence can respond to those limits in different ways. One response is escalation. Another is adaptation. Another is acceptance. Our fascination with lost civilizations often reflects anxiety about our own limits. If others rose and fell, what does that say about us? If they vanished quietly, what does that imply about our future? The thought experiment does not answer those questions. It frames them. It also reveals how deeply we crave narrative closure. We want beginnings and endings, first civilizations, last civilizations, turning points that make sense in hindsight. Earth does not provide those. It offers overlapping processes and gradual transitions. Learning to think in those terms is uncomfortable, but it is also more accurate. Another thing this idea reveals is how we relate to the unknown. Some unknowns invite exploration, others provoke defensiveness. The difference often lies in whether the unknown threatens identity. The possibility of earlier civilizations does threaten a certain identity, not individual identity, but species-level self-conception. Are we pioneers or participants? Are we authors or characters? Neither answer diminishes the experience of living, but the shift matters emotionally. The comfort that eventually emerges from this thought experiment comes not from resolving the question, but from realizing that the question does not need resolution to be valuable. It does not need to tell us what happened. It needs to show us how we think. It shows us our attachment to permanence, our discomfort with ambiguity, our tendency to project ourselves backward, our hunger for validation from deep time. Seeing those tendencies clearly is a form of self-knowledge, and self-knowledge, unlike geological evidence, does not erode. There is also something grounding about recognizing that Earth has hosted countless configurations of life, climate, and landscape without reference to us. That recognition reduces the sense of cosmic pressure. We do not have to carry the burden of being the culmination of everything. We are allowed to be temporary. That permission can feel surprisingly gentle. It allows us to focus on quality rather than quantity, on depth rather than reach, on care rather than conquest. If permanence is not guaranteed, then attention becomes more valuable than ambition. The thought experiment does not demand that we change how we live. It invites reflection on why we live the way we do. As we approach the end of this line of thought, it becomes clear that the most important outcome is not an answer about the past. It is a shift in perspective about the present. We stop asking whether Earth remembers us. We start asking how we relate to a planet that does not. That shift is subtle, but it changes the tone of everything that follows. It moves us away from proving importance and toward practicing responsibility. It moves us away from legacy and toward presence. The idea that we may not be first or last or remembered does not empty life of meaning. It strips away unnecessary expectations and leaves something simpler behind. We are here now. We are thinking. We are capable of care. That is enough. The thought experiment in the end reveals less about lost civilizations and more about the stories we tell ourselves to feel anchored in time. Seeing those stories clearly does not require us to abandon them. It requires us to hold them more lightly. And from that lighter grip, a different kind of clarity emerges, one that does not depend on answers buried in stone, but on how thoughtfully we inhabit the brief moment that Earth has made available to us. There is something quietly grounding about placing our lives against a backdrop that does not centre us. A very old world has a way of softening urgency, not by dismissing it, but by putting it into proportion. When we remember just how long Earth has been here, and how much has unfolded without witnesses capable of reflection, the present moment begins to feel both smaller and more precious at the same time. Living briefly on a very old world is not a tragedy. It is a condition. Every organism that has ever existed on this planet has lived briefly by geological standards. Even the most successful species, those that dominated ecosystems for tens of millions of years, passed through their moment and vanished. Their disappearance did not erase the reality of their lives. It simply marked the end of their participation in a system that continues to change. Humans often struggle with this scale because our daily experience is built around continuity. We plan for years. We measure progress across decades. We imagine futures that extend beyond our own lifetimes. These habits are necessary for social organisation, but they can also obscure a deeper truth. Continuity is something we create locally, not something Earth guarantees globally. The planet does not promise permanence. When we step back and consider the full span of Earth's history, our civilization becomes one arrangement among many. Not insignificant, but not central in the way our stories sometimes imply. This does not diminish our achievements. It reframes them. It places them within a larger pattern where emergence, persistence, and disappearance are all normal outcomes. Living briefly means that meaning cannot depend on duration alone. If meaning were measured purely by how long something lasted, then almost nothing would qualify. Mountains erode, oceans shift, continents break apart. Even the most durable features are temporary given enough time. Measuring worth by endurance sets a standard that nothing on Earth can ultimately meet. Instead, meaning emerges from experience, interaction, and influence within a given moment. A brief existence can still be rich. A short-lived system can still be complex. A transient civilization can still matter to those who lived within it. This perspective becomes especially relevant when we consider the possibility that Earth may have hosted other intelligences before us. Whether that happened or not, the exercise of imagining it draws attention to a deeper point. The value of a civilization does not come from its ability to be remembered forever. It comes from how it navigates the constraints of its time. Those constraints are unavoidable. Earth's climate changes, resources fluctuate, geological processes reshape the surface, life adapts or disappears in response. Intelligence does not stand outside these forces. It arises within them and is shaped by them. No amount of planning or foresight can remove a civilization entirely from planetary dynamics. Understanding this can feel unsettling at first. It challenges the idea that progress naturally leads towards stability or permanence. It suggests that even the most advanced systems remain vulnerable. But vulnerability is not the same as futility. Vulnerability simply means that outcomes are not guaranteed. Living briefly on a very old world encourages a different orientation toward time. Instead of asking how long something will last, we begin to ask how it functions while it exists. Instead of focusing on legacy, we focus on quality of interaction. Instead of striving for permanence, we attend to balance. This shift does not require abandoning ambition or curiosity. It requires adjusting expectations. Much of human anxiety about the future is tied to the desire for continuity. We worry about whether our institutions will survive, whether our knowledge will persist, whether our efforts will matter in the long run. These concerns are understandable. They motivate care and foresight, but they can also create a burden that distorts decision-making. When permanence becomes the goal, short-term harm can be justified in its name. When legacy becomes paramount, present responsibility can be overlooked. A very old world does not reward that logic. Earth has seen countless attempts at stability. Some lasted longer than others. None lasted forever. What persists longest are not structures or systems, but processes that remain flexible enough to adapt. Life itself is the clearest example. It has endured not because any single form was permanent, but because variation, adaptation, and turnover allowed it to respond to changing conditions. Extinction and emergence are part of that endurance. Civilizations, as extensions of life, may follow similar patterns. This does not mean collapse is inevitable, or that effort is meaningless. It means that success may need to be defined differently. A civilization might succeed by minimizing harm, maintaining balance, and fostering well-being during its existence, even if it does not persist indefinitely. From this perspective, the idea of living briefly becomes less frightening. Briefness does not imply insignificance. It implies context. Every human life is brief relative to Earth's history, yet individual lives are filled with meaning, relationships, creativity, and care. We do not dismiss personal experiences as trivial simply because they end. We understand that finitude gives them shape. The same logic can apply to civilizations. If an earlier civilization lived briefly on this old world and then vanished, its disappearance would not retroactively strip meaning from the lives lived within it. The absence of a record would not negate the reality of those experiences. Accepting this helps soften our response to uncertainty. We do not need to know whether we are the first or the only intelligence Earth has hosted to live thoughtfully now. Our actions do not require validation from deep time. This realization can be liberating. It allows us to let go of the need to be exceptional in a cosmic sense. We can focus instead on being attentive participants in the moment we occupy. We can ask how to live well within constraints rather than how to transcend them. A very old world invites humility not as self-negation but as perspective. Humility reminds us that Earth is not a stage built for our performance. It is a system that existed long before us and will continue long after. We are guests, not owners, participants, not directors. This framing changes how responsibility feels. If we believe our civilization must last forever to justify itself, failure becomes catastrophic. If we accept that no civilization lasts forever, responsibility shifts toward how we treat the world and each other while we are here. Care becomes local rather than eternal. There is also something quietly comforting about recognizing that Earth's age makes room for many stories, not just ours. The planet does not revolve around a single narrative. It holds layers of history, most of which are inaccessible to us. That vastness reduces the pressure to resolve every mystery. Not everything needs closure. The silence of deep time, which can initially feel frustrating, becomes easier to live with once we stop expecting it to answer our questions. Silence does not always mean absence. Sometimes it simply reflects the limits of preservation. Living briefly on a very old world means accepting that some questions will remain unanswered. That acceptance does not dull curiosity. It refines it. It encourages careful inquiry rather than certainty-seeking. It also encourages patience. When we slow down enough to consider Earth's timescales, urgency recalibrates. Immediate crises remain important, but they are seen within a broader context. Panic gives way to deliberation. Reaction gives way to reflection. This does not solve problems, but it changes how we approach them. A civilization that understands it is temporary may be more cautious about irreversible actions. It may value resilience over speed. It may prioritize adaptability over dominance. These are not guarantees, but they are possibilities opened by perspective. The idea that Earth forgets civilizations is not meant to inspire despair. It is meant to clarify what forgetting actually means. Forgetting does not erase experience. It erases record. The distinction matters. We often conflate being remembered with having mattered. Earth does not make that association. It allows things to matter intensely while they exist, and then it moves on. Learning to live with that reality can change how we think about success. Success becomes less about carving a permanent mark and more about maintaining balance, fostering connection, and responding wisely to conditions as they arise. This perspective aligns closely with how ecosystems function. No single species defines an ecosystem's value. Interactions do, relationships do, flows do. When conditions change, the system reorganizes. Civilizations are ecosystems of another kind. They involve flows of information, energy and resources. They rely on cooperation and competition. They adapt to constraints. They fail when adaptation breaks down. Understanding this does not require imagining earlier civilizations. It simply requires looking honestly at how systems behave over time. The thought experiment of earlier civilizations serves as a reminder rather than a revelation. It reminds us that Earth has hosted complexity repeatedly. It reminds us that intelligence does not guarantee endurance. It reminds us that permanence is not the default. From that reminder comes a gentler way of inhabiting the present. We do not need to hurry to justify our existence to the future. We do not need to prove that we are unprecedented. We do not need to fear that forgetting nullifies meaning. We can focus on how we live now. Living briefly on a very old world invites attentiveness. Attention to the ground beneath us, which has been reshaped countless times. Attention to the air we breathe, which has supported very different forms of life. Attention to the relationships that make our moment coherent. This attentiveness does not require certainty about the past. It benefits from humility about what we cannot know. There is also a quiet solidarity in recognizing that everything living now shares this condition. Plants, animals, microbes, ecosystems, all are temporary participants. None are guaranteed remembrance, yet all contribute to the ongoing story of life on Earth. That story does not need an audience. It unfolds regardless of who is watching or recording. It is self-sustaining, self-modifying, and indifferent to recognition. Intelligence, when it arises, becomes part of that unfolding rather than its conclusion. Seeing ourselves this way reduces isolation. We are not standing apart from the planet. We are woven into its processes, subject to its limits, shaped by its history. This does not diminish wonder, it deepens it. There is wonder in knowing that Earth has changed so much and still supports life. There is wonder in knowing that intelligence can arise within such change. There is wonder in recognizing that our brief moment is one expression of a much longer dynamic. Living briefly on a very old world also encourages care for the future without obsession over legacy. We can act responsibly not because we expect to be remembered, but because actions have consequences for those who share the present and those who come after, even if they never know our names. Responsibility does not require permanence. It requires awareness. The thought experiment we have followed does not end with an answer about ancient civilizations. It ends with a shift in posture. We move from seeking validation in deep time to finding grounding in the present. Earth's age teaches patience. Its forgetfulness teaches humility. Its continuity teaches resilience. Together, these lessons invite a calmer way of thinking about our place here. We are not the center of Earth's story, but we are part of it. We do not need to dominate the narrative to participate meaningfully. This realization does not close the discussion. It leaves it open in a different way. The past remains vast and partially inaccessible. The future remains uncertain. The present remains the only place where action and experience occur. Living briefly on a very old world means accepting all three. It means allowing the past to be larger than our understanding, the future to be open-ended, and the present to be enough. That acceptance does not quiet curiosity. It gives it room to breathe. As the planet continues its slow, patient work of change, we live, think, and choose within the brief window available to us. Whether or not others lived here long before us, whether or not traces remain, this moment is real. And within this moment, meaning does not depend on how long it lasts. It depends on how it is lived.